Well, good morning, everyone, and welcome to Huntsville. For those who aren't from here, I actually live here in Huntsville and commute down to the Bankhead. So those that will be there tomorrow, welcome to the Bankhead as well. I'm very happy to be a host of the ARM program. As Nikki said, it's been an interesting experience getting everything set over the last several years, but very happy that it's up and going and very much look forward to the continuing collaborations ongoing over the next few years. So wanted to go over just a little bit about what the Bankhead is. Some of you may know something about National Forest, some of you may not. So this is going to be kind of a crash course in what National Forests are and what we specifically at the Bankhead do. So this is the overall National Forest system. If you don't know, the National Forests are actually within the U.S. Department of Agriculture. You would think that we're interior, but we're not. There's a very interesting history that goes back to the first chief of the Forest Service on why we're in agriculture instead of interior. But you can see there we've got about 192 million acres, 154 forests and grasslands, and 43 different states have a national forest and grassland. So that you can see the scope of the overall national forest in the U.S. Here in Alabama, we're known as the National Forests in Alabama. You may have questions about what's the difference between a forest and a district, why the Bankhead is known as the Bankhead National Forest, as well as the Bankhead Ranger District. Ask me afterwards. It's a whole bureaucratic thing that I'm not going to get into here. It's kind of, if you get into interesting details, I like it, but it's not relevant. So there's 4 different proclaimed national forests, basically 6 districts. For all intents and purposes, the National Forest in Alabama is supervised out of Montgomery, and then each district, which the Bankhead National Forest is just a district, each district has a district ranger in charge. As you see there, we've got about 670,000 acres here in Alabama under National Forest management. The Bankhead specifically is about 182,000 acres, and you can see there 3 different colors. The dark green is, well, all of the colored part there is Bankhead National Forest, so you can see how it's got both some areas of very contiguous forest cover in terms of our forest ownership, national forest ownership, and then also some areas that are very split up within private ownership. And that private ownership is mostly forested with some small agricultural, usually grazing for cattle or horses. Not a lot of row crops at all. The soils are just too poor for it. It's one reason why it's still in forest. The lighter green is a state level jurisdiction, so that is a wildlife management area. I tried in all of my spots to remove any acronyms because I knew that there was going to be plenty here from the ARM program. I didn't want to add any of the Forest Service ones, but we are a federal agency, so we have hundreds of them. If I missed one, I'll try to catch it here. But the WMA it's still our land, but the state Department of Conservation Natural Resources, Wildlife and Freshwater Fisheries Group, they manage the game populations differently. So it's a hunting rules difference is really what that lighter green area is. Again, we still manage it, the terrestrial side the same, they just manage the hunting differently. Then the yellow part there, as you see, is the Sipsey Wilderness. It's about 27,000 acres now, or 26,000 acres now. It's one of the largest wilderness in national forest lands in the eastern U.S. So very, very popular for recreation. As you saw on the title slide, we're known as the land of 1,000 waterfalls. That's really not an exaggeration. We have dozens that are named, and then pretty much any creek is going to have little small waterfalls anywhere you go on it. So very highly sought out for recreation within that wilderness area. If you don't know what a wilderness area is, it's essentially, it's a roadless, non-mechanical, trying to allow natural processes to be the primary driver. It's there for the enjoyment of the public, but other than some rudimentary trails, it has no real facilities. There's very little signage of the trails. It's only at intersections. It's meant to be what you might think of as a wilderness. And so I'll come up later on when we talk about working together in a research, but some of you may look at that as, oh, that's a great place to do some sort of a control type thing. Please note that even doing any kind of research in the wilderness adds a whole nother level of review that it's hard to overcome that one because we try not to use that. Now, one other layer in there is actually a research natural area located inside the wilderness. So there's actually 4 different jurisdictions to speak of. We also have the Sipsey Fork of the Black Warrior River, the only wild and scenic river in Alabama. Many of you, if you're here enough, you'll see signs that say Sipsey River. That's actually a completely different river and a different river system. So when you cross the river, it's going to have a sign that says Sipsey River. It's not. It's actually the Sipsey Fork. The Sipsey River is to the southwest of here in the Tombigbee River system, not the Black Warrior. So just one of those things. So we do multiple use management, and that means that we do all sorts of ecosystem management in terms of active forest management. We're actively trying to restore the forest to these different kinds of forest types. Back in the 80s and 90s, there was a big push to convert much of the forest to loblolly pine plantations for wood products. Since then, we've been actively trying to get it back to more of the natural ecosystems. I didn't realize that there was a nice little spot here. I can see what it is without looking back. That's great. So we use a forest restoration model that includes a number of different factors, but really it comes down to trying to manage the species, the structure, and the function. And with species, it's the different kinds of trees that we're trying to manage for, but also those trees have specific attributes such as mast or other foods for wildlife, specific grasses, forbs, those kinds of species. We're trying to manage for a full host of those that are natural to the area. Then within structure, we manage that largely with different mechanical attributes, whether we're doing some sort of commercial thinning or other, literally affecting how many trees are out there. And then function is largely determined by a fire frequency and the use of prescribed fire to provide different functions and have a different impact on what's out there. So, like I said, we do that through a number of different types of activities. We do thinning, artificial and natural regeneration, tree release. So that means that we're actively, if we're trying to restore certain native pines, specifically longleaf and shortleaf pines, we're trying to restore. We don't do any loblolly pine planting because we're trying to restore it to the more native species of loblolly and shortleaf. We do that through artificial. We plant them after a clear cut. But then we're also looking to try to increase our hardwood regeneration, oaks and hickories. That is mostly a natural regeneration project. We do prescribe burning about 20,000 acres. I'll talk a little bit more about that. I know many of you, when we're talking about atmospheric things, that comes in, oh, great, we're gonna, what all's going on there? How can we work with prescribed burning? And I'll go over that in a little bit more detail. We do about 20,000 acres of our 180,000 acres each year. Then we do non-native invasive species control. That's both, herbicides for plant, and then also another invasive species that we do quite a bit of work on are feral hogs. So the wild pig population is very bad. As you'll see in some future things, our water resources are extremely important to us, and those feral pigs really cause problems in the water. So here's our prescribed fire. So the map you see there is all of the potential blocks that we may burn. So if it's not in one of the yellowish colors, it's not burned. We have 2 different general rotations, a short rotation, which is about every 2 to 3 years that we burn the same block. and then a long rotation, which is between 5 and 10 years. So those have differing effects on the vegetation and the areas. We burn, like we said, about 20,000 of those acres of those each year. And we know for each given season, which is generally January through May, we know which ones are planned. We don't know when they're going to be. And literally when I say we don't know when they're going to be, that's to the morning of a burn. We do not know ahead of the morning before. We may know which ones we'd like to do, but everything comes into play each day. Wind direction, wind speed, relative humidity, all of that. My job as the agency administrator is I have to look at all of those different factors to determine whether that burn can be pulled off or not. So one thing you might hope is that, oh, we can know that this burn's going to be done on Friday, starting at 9 o'clock. And yeah, sorry, that doesn't really happen. We'll work with you to the extent we can, but it's really not, it doesn't work that way. So the Bankhead is very well known for its unique biodiversity. We are a very broad area for species. We've got over 200 birds that fly through. We are known for 21 threatened and endangered species. Your sticker, if you happen to see it, you'll see a couple bats flying on that sticker. We have a couple endangered and threatened bat species. That was on the sticker partly because Patty, one of the big parts of the NEPA to get the site, the trees harvested, has to do with the bat window. So harvesting trees during a certain window doesn't affect bats. Harvesting them out of that window can affect bats. So it was a whole thing. Teaching everybody about bat ecology was kind of interesting. And then we have many, many more rare species, spotted skunks, blue-faced darter, glade plants. We have some very important game animals. We're very well known within the WMA as having some of the largest deer taken in the state. You can see there from just a couple of years ago that a 250 10-point buck is very, very large for the South. For those that are from the Midwest, those are more common in terms of size. And one of the reasons is most of our deer actually have genetics from Michigan and Wisconsin. Many, many years ago, the deer population was decimated, so they brought in a bunch of northern deer to repopulate. Here's some just very rare aquatic species. The upper left is the black warrior water dog. That's really only known to a couple streams here around the Bankhead. The flattened musk turtle is on the bottom right. That's another one that's only really known within the Black Warrior watershed. The upper right is a mussel. I don't know which one, but we've got 6, I think, that are within the threatened and endangered category. So our aquatic issues are very, very important. We've got over 3,000 miles of streams. 4 different locations are public water sources. Sipsey Fork has a special designation of an outstanding national water resource. And then on the southern end is the Lewis Smith Lake Reservoir. It's a hydroelectric dam run by Alabama Power. So it's about 21,000 acres. They actually have a special use with us because they're occupying much of the Bankhead property in that area. As a national forest, even though we're not a park, because we do all of the active forest management, we also provide very much recreation. Everything from camping, horseback riding, ATV riding, lake fishing, stream fishing, hiking, the whole 9 yards if you can, shooting range. And then of course our biggest recreationists are our hunters and fishermen. That's one that doesn't often get reminded, but very, very big recreation. We're very involved with the community. The Bankhead is well known. We have had a group called the Liaison Panel ever since the early 2000s. It's not something that is all that common in the Forest Service, but we have almost quarterly meetings with the public. The armed folks have been and presented once, but we have a very engaged local public who like to know what we're doing and can at times be very vocal. I would ask that if you're having any concern, if you're hearing anything, if you're working in the area, please come to me and help me and let me help you work with that. Our public works with us very well, but it's because we have worked very closely with them over 20 some years to develop that trust. Science support, getting to what you all are here for. I threw some of the major universities and the Southern Research Station, which we've got a table over here that two Southern Research Station scientists, and which I used to be. So that's one of the reasons why I kind of have an interest in the science and why I saw the opportunity to help. I was a Southern Research Station scientist in the Forest Service for about 15 years before I came back to the Bankhead. All of these universities we work with, not just approving research, but actually actively working with them on a number of projects, as well as the full range of federal and state alphabet folks, from Fish and Wildlife Service to USGS to EPA to the state DCNR to Alabama Natural Heritage Program. We've even worked with folks such as the New York Botanical Society. We've worked with the Atlanta Botanical Society, a whole number of groups. We probably get anywhere from, I'd say, 15 to 20 different research requests a year that have nothing to do with art. Because of all the different diversity we have, we get a lot of people that want to come study all sorts of different things. So kind of what Nikki said, her document has this spelled out really well, but just kind of some basic ideas of how to work with us. Again, I'm here, for one, I'll be very active trying to help foster collaboration. The Bankhead collaborates very well. We get so much more done by working together, and I'm happy to help collaborate with that and help find people that are working on something similar. By federal regulation, any activity that happens on the forest has to be permitted, okay? So that can be either simple, where we can just provide a letter that says, yes, go ahead, or it may have to go through what's called a special use permit process. I'm not gonna go all the way through this. Nikki's documentation has a very similar write-up, but basically, if it's gonna have an installation where it's gonna stay there for a few days or longer, or if it's going to have soil disturbance, it's likely going to take more review and permitting than if it's just measuring trees or counting vegetation or something. Those are kind of the differences. But we're very good about trying to help connect with other partners. We know a lot of different people, again, from federal, state, local, et cetera, happy to help do that. Some of the other things that we really can't help with, we get asked all the time, but because we have all these different factors that we do management, we just don't have the time to do for each group. Things like what kind of trees are under the tower? We've actually already been asked that. So, no, we're not gonna go out and measure the trees for you under some site to tell you what the vegetation is at a certain location. We don't have the capacity to do those kinds of supports. We can't burn specific areas or specific days. It doesn't work that way. If you're trying to get places, trees fall all the time. We're in the middle of the worst southern pine beetle outbreak ever that we know of. It's even worse than what the original one was back in the early 2000s. So trees are going to be falling all the time. We can't rush out to get to a road because you showed up and your favorite location happens to be blocked. We'll get to them, let us know, but it's not an immediate thing. And with that, happy to answer any questions. I will be here all day, and I'll be at the tour tomorrow afternoon. Happy to meet with any of you and talk about what else we can do, anything else you want to know about the Bankhead.
Any questions? Oh.
Just curious whether or not you guys are collecting any water quality information along the streams.
Yeah, question of, do we collect any water quality? So yes, we do, in a number of different ways. The Bankhead itself doesn't, but that's where we work with a number of partners. So I know that USGS has done some different water quality sampling. I know that there's a USGS monitor on the district. The Alabama Department of Environmental Quality does water quality sampling. The Alabama Water Watch, it's run out of the Auburn Extension. They do some water quality sampling. Then we've got a number of projects that are looking at the aquatic, resource in terms of species that do eDNA and other things like that, mostly out of the Alabama Department of Natural Heritage and Jim Godwin down at Auburn. They do a lot of eDNA work for us.
So these are the kinds of things we're hoping to kind of capture in the notes. And even what Andy said, trees under the tower. So that's not something that they're normally going to do, but that might be something that ARM creates, some knowledge base on, things like that is more associated with what we're doing there, or why we're doing there. So please put those things in. We rarely say no, but if there's a reason, we will say no, but we might be able to create some better mapping. We were talking about that yesterday at one of the supplemental sites of truly capturing the edges of the agricultural field and the grassland that's between that, and where our instruments are exactly and precisely within that. So please throw those things in the notes and we'll see what we can do. And hopefully Mark's capturing everything that you said.
Doing my best. Andy, there was a question. You had showed the rotational map of burns every 5 and 10 years maybe. Is there a copy of that is KMZ or a GIS that folks could have access to?
Sure. Yes.
I can't be the only person who wants to know if that was a turtle on top of another turtle.
Yes.
Okay, thank you.
Thank you, Andy. So we're going to do a lot of great science with this new facility. Is there something that y'all have a gap in your day-to-day operations that maybe we should help y'all with as we do our science and create new algorithms and new products?
That's a great question. And what I would say is generally Forest Service management is very slow to change because of all of the different things we have to take into place. We try to work within kind of an adaptive management framework, but frankly, the science is largely so far ahead of where we are management-wise that I wouldn't say that there's specific gaps we have. The things we tend to support research-wise ourselves tend to be species-specific. Things where we have a known threatened endangered species, rare species, that we need to know more about their habitat needs so we can manage for them. That's the things that we tend to need to know. As a agency, that's a different story. That's one of the reasons why we've got the Southern Research Station here. Kelly Schweitzer, who's right back there, I'll tell you, she's got one of the best long-term field-based studies. It's 22 years old now. We just passed 100 prescribed burns where they monitor each time. So if you want to talk to somebody who knows the intricacies of trying to actually pay attention and work with us on prescribed burns, she's been amazing to work with for over 20 years. And that's the kind of thing that we do, is we work with them, but generally know at the management level, we're way behind where the science is.
Andy, I've got one for you. Back over here.
Yep.
There's a question online about drones. They mentioned there's a drone corridor in Alabama with relaxed FAA restrictions for drones. Does that transect BNF? Special comments from you on drone operations in and around the forest and wilderness area?
Yeah, so drones within the forest are, generally speaking, recreational drones. Our policy there is it must be line of sight. And there aren't restrictions to, say, recreational drones within the general national forest. The wilderness is a different story. So there's an FAA circular that requests that they stay above 1,500 feet and to not have any landings. So that would mean that you would have to start the drone from outside the wilderness. You could walk in, having it fly 1,500 feet above your head, but within line of sight, and then you'd have to leave again before you brought it back to the earth. So the drone can't land in the wilderness anywhere, or it becomes, that's actually against wilderness regulations. The FAA circular is a advisory, it's not a law, so to speak. But otherwise, and we can work with that kind of stuff because there is a lot of, we do use drones for prescribed burning. If we had any wildfire, we might be using helicopters, and so there can be temporary flight restrictions when we're doing some of those kinds of things. But we can work with you.
Thanks, Andy. And I just want to reiterate for folks, if that's something that you're wanting in a proposal, please submit it, and we will review these things, and we'll work with folks like Andy and his team to make sure that we have all the correct guidance for you.
Thanks, Andy. I have a quick question. For the prescribed fires, although we cannot control the specific dates or where it is, but after that, do you document how large the area you have burned and how long you have burned, and how this control you have for this prescribed fire?
Sure, yeah. So the question about, do we document how big the burn is and when it was and everything? Absolutely. And in fact, the map I have here is of the sum total of all the possible burns. We also have a current map that's saying which ones are we going to burn this year. So we know which ones will likely be burned this year. When exactly is another story, but we know what the size is already, and we do monitor, because they're generally set sizes. Sometimes we might have to split the block like in two and then come back and do the second half later. But yes, we document all that, and generally we can provide that, yes. But we can definitely provide the map of where we're going to be burning this year. And it's actually, there's an online version that you can see after we have finished. It's uploaded within a couple days showing that we have completed a block. So there's actually an online version of that.
On those, after you've completed them, are they accurate to, because you're doing it in a prescribed area, how often do you need to update that based on what happened that day?
The block size is generally known because we burn to known lines. They had to be put in for archaeological surveys, whole 9 yards. It's either roads or known lines that we've already put in. It might be cut in half or something if we couldn't finish it. But again, that would show up on that online map where it was actually burned versus where it wasn't.
So I've got the burn accomplishment tracker link. Yep. Can I go ahead and share that with folks?
Yeah, absolutely.
Okay.
That's an online public resource.
Okay.
Hunters love that because the turkey hunters love to come in the day after a burn.
Thank you.
Any information about the intensity of the burn once it's done?
Not to the level that most scientists would want to know.
All right. And one last question. Any additional monitoring of the stream water after the burn?
Currently, no.
Okay.
That would be more of a specific project. Now, to your point about any burns that we know intensity, so again, the few that we have several planned this year with Dr. Schweitzer. They do some measurements that look at, and going back to the 100 burns in past, they would have some vegetation management, and you actually do temperature recorders, don't you? Yeah. So that's where we work and collaborate. The Forest Service doesn't. We note 90% done, 70%, not really a intensity measurement that anybody could use anything with. Very qualitative. But with partners, we've been able to do some more specific.
Okay, anything else for Andy? All right, thank you.
Hi, I'm Sean Freeman. In addition to running around with a microphone this morning, I'm also an assistant professor in atmospheric and earth science here at the University of Alabama in Huntsville. We're really happy that we were able to host you here at the University of Alabama in Huntsville. Great to have you. We're really excited about the BNF facility that ARM has decided to put. It's only about it's about an hour from UAH campus proper, not too far from Huntsville. So this session during lunch is really designed to give you an overview of the kind of facilities and capabilities that we have here at UAH and the Department of Atmospheric and Earth Science and the Earth Systems Science Center here. And so I think I speak for everybody, all the PIs that are going to be coming and talking about their instruments and labs this afternoon, that we're really interested in partnering with you all on various proposals and other sorts of things. And so this just gives you an overview, a taste of what everybody has available. We've got 6 different people that are going to be speaking about different facilities available here at UAH. We'll start out with Kevin Knupp, who's going to be talking about the MapNet facility. Dr. Knupp is a professor emeritus here at UAH and a principal research scientist in the Earth Systems Science Center.
Okay, thank you. I'm going to talk about the MapNet Mobile Atmospheric Profiling Network and what one can do with that. What am I doing wrong? File's too large. So as you see, the MapNet consists of 4 platforms, 3 profiling systems, and this is one of the profiling systems here, and 1 scanning radar. And I'll just go through these really quickly in turn and describe their instrument capabilities. Okay, thank you.
Very sorry to interrupt. Oh, there we go. We can see the slides now. We were not able to see them before. Thank you.
Okay, so MapNet is funded by supported by the National Science Foundation. And I'll also put a plug in quickly for the Dow facility, which is also now at UAH. So these are the platforms right here. Upper left is the Mobile Integrated Profiling System. Upper right is the RADAPS. Similar to the MIPS, lower left is the modals. And I guess I accidentally hit that, but the FARM system, flexible array of radars and mesonets, consists of, I believe, 5 radars now and 4 trucks. They're located in Boulder, so we call that UAH West, that campus out there. But getting back to the MIPS here, this is the MIPS deployed for a landfalling hurricane. Instrument list is on the right. 915 megahertz wind profiler, X-band profiling radar, microwave radiometer, oscillometer. I'll skip over that number 5 there for now because that's usually on the modals. And then other instruments that measure raindrop size distributions like disdrometers, in situ sensors, and one can actually add a Doppler SODAR to the suite of instruments on this platform. Here's the RADAPS. It's similar, smaller footprint, but similar instruments. Not quite as comprehensive. And this is the modals. Picture in a field deployment in the upper left here. The exciting thing with modals is the addition of a Ka-band radar. It's currently being built, I think, final stages of construction at Pro Sensing, and we should take possession of that in about a month time frame, hopefully. But it's a lot like the Kaiser radar out at M1, I believe. Different kind of system, though, but similar in specs, sensitivity, and things like that. It also has, Modals also has a Doppler LiDAR, so we'd have a Doppler LiDAR along with a Ka-band radar on the same platform. Recent deployments for the systems are listed here. Vortex Southeast over 5 or 6 years, Perils over 2 years, and then most recently the deployment on the Eclipse in Texas. And this is that deployment right here. So we set up the MapNet in a triangle. It's that green triangle that you see in the lower left there. And then the MAX and RADAPS were at the center. So we put MAX out there so we could monitor changes in bird flights around the area as we went from daylight to darkness in the eclipse and back to daylight. I'll say a few things about how one can fit MapNet into AMF3 here. So this is the AMF3 network. You've seen this picture many times, I would assume. And what one can do with MapNet is you can expand. You could expand the network. So here you see the AMF3 triangle in black, and then additional triangles formed by modals to the west. RADAPS would be up above the top of the screen to the north, and then MIPS is here, which would typically be running 24/7. So you go from one triangle to 4 triangles and double or quadruple the area, the effective area of what one can do on the larger scale than the AMF3 triangle. For example, you could do Green's theorem type circuit analyses to look at advection and vorticity and divergence over a much larger area than just AMF3. Or you can use MapNet as a network filling mechanism to get more profiling systems in a smaller area to really get a better handle on heterogeneity. So that's another option. Being mobile allows one to use MapNet in a very flexible way and tackle any science objective that someone might have. So MapNet would be available for investigators. If you have a science problem that you would like to use MapNet for, you can contact me. I've also looked at the Doppler radar coverage over the network. And again, here on this slide, the AMF3 triangle is in yellow. And then the curved red line would illustrate the Doppler radar coverage, assuming that we put the MAX radar at the Cortland Airport. So that expands coverage out to the west. And again, MAX is a mobile radar, so you could position it elsewhere. For example, if we put it off to the west here at X3, then there is, I would judge, pretty good dual Doppler coverage over most of the AMF3 triangle, including M1. Okay, so with that, I wanted to keep this short. Did you want to take questions now, Sean, or later?
Yeah, we'll take a question or two now for Kevin.
This is slide. I think before questions, I just want to say thank you to Kevin. He did so much work with all of his work prior to ARM coming here that helping us cite the radars, it really cut that down to deciding which of the choices he provided were actually going to work for us. So we really appreciate that. But questions?
If not, I believe all of us are, look, we work here, so many of us are going to be around here for the rest of the day and probably into tomorrow. So up next is Preston Pangle, who is a research associate in the Earth System Science Center. He's going to be talking about the ARMOR radar, which Kevin mentioned, and then also the swirl facility.
Thanks, Sean. Okay, I will wait. There we are. Okay. So as Sean introduced, my name is Preston Pangle. I act as the data and facility manager of the MapNet instruments. So it is my job on all of those instruments to make sure that they're running. So brief overview of the Swirl facility. I don't know how many of you know what's across the street. So I just wanted to kind of briefly go over what Swirl is, where we work, where the MapNet instruments are housed. So this is a picture of Swirl. And so it was officially commissioned as a response to the 2011 April 27th tornado outbreak that we had over this region. The state funded it to be built to better understand the severe weather that we have in the southeast U.S. So some key features that I'll be highlighting include the high bay, operations center, classroom, conference room, so on. So I'll go through these fairly quickly. So this is our research operations center that we have inside the building. So it's actually on the second floor. You see the big, it doesn't look as big on this screen, but you see a big 9-panel video wall that connects to multiple different computers that we have lined across the room. So we can actually use this as an active research operations center for field campaigns, like you see in these pictures, or in this picture. So this was during Vortex Southeast that was hosted here around Huntsville area. Not only do we use that as like an actual hub for field campaigns, we can use that as a conference room, special guest speakers, and student workstations. We do have these windows in the picture in the bottom that face the southwest, so we can all do our cloud watching and storm watching as the storms come in. But thankfully, those windows are rated at 250 miles an hour, so no harm there. Not pictured, I should say, I guess. There is because it is on the second floor in a tornado-prone area, we do have a tornado shelter adjacent to the operations center. So highlighting some of the labs and high bay garage. So on the first floor, we have lightning and electronics labs. So 2 separate labs. One is dedicated to lightning sensor manufacturing testing. I think Dr. Philip Visser will be giving a short talk about some of the research he's doing lightning-wise. And so his group is doing a lot of lightning research using these lightning sensors that are developing here at Swirl. And then we also have a separate electronics lab that's used for sensor manufacturing, testing, and such. And then we have a sounding lab, sounding prep room. That's where we use that's what we use to store all of our sounding equipment. So we have the capability to deploy 6 mobile radio sound systems with or separate from our MapNet instruments. And then we also can launch from here. So the National Weather Service here in Huntsville, they don't launch radio sondes twice a day like some of the other offices do, so we can support them for special operations. And then the high bay garage pictured down at the bottom, it's a 5-bay garage that has a 5-ton crane that we can use to manufacture and maintain our instruments. We then have some classrooms and office spaces scattered about for various student activities and classes. And then a couple of other key things that we have is the berm that is on the top right. So that has a 10-meter tower and is outfitted with temperature measurements at 10 to 1.5 meters, as well as 10-meter wind and other in situ measurements. We have the capabilities to host guest instruments there. We have power and Ethernet for any guest instruments there. And then we also have these roof platforms that I wished would have shown, but they didn't. On the roof there are 4 main platforms that have power and Ethernet that can be available for guest instruments. I think currently we have maybe 3 guest instruments on the roof right now. And then getting to the Armor radar that Kevin had mentioned already. So we have not necessarily a part of the MapNet facility, but a UAH asset. The Armor radar is located out of the Huntsville Airport. It's about 15 kilometers southwest of here. It's a dual polarization C-band radar. We have direct data access and control from the Research Operations Center. And it was built as a collaboration between UAH and then NASA Marshall. So a brief overview that kind of hits some key points here that might be interesting to you. It was designed by the Barron Weather Services. It's 350 kilowatt magnetron. Its typical range is 100 to 120 kilometers, so you can kind of see very faintly in that red circle its range. And then pull in a graphic that we kind of was already shown. It's got about a 33 kilometer baseline of the CSAPR 2. So we have the abilities to do PPIs, RHIs, typical radar stuff. It's very user customizable. And then some activities we use the radar for include the DC3 campaign back about 12 years ago, I think. Vortex Southeast project from 2015 to whenever it ended, 2020. And then perils. And then we do some local ops. And then, as I mentioned, the National Weather Service Huntsville is just located next door. So sometimes they may ask us to operate the radar for some specific things that they need for situational awareness or for ourselves. So that is an asset that we could utilize, as Kevin highlighted, for various science goals. So yeah, that's all I have. Thank you.
And if you look out past the United Gates at the Huntsville Airport, you will see armor. Any questions for Preston? Seeing none. All right. Up next is Mike Newchurch, who is a professor in the Department of Atmospheric and Earth Science here at UAH. And he will be talking about rocket and other sorts of air quality instruments.
Thank you all for coming. We were in Chicago not too long ago in the summer of '23, making a lot of measurements near the Argonne home. I'll show you some of that. We're associated with a international constellation of satellites, Tempo over the United States, GEMS over Asia, Korea in particular, and an upcoming European satellite, Sentinel-4, over the European continent. We founded and managed the TollNet Tropospheric Ozone LiDAR Network, which comprises LiDAR stations from California to New York. That's in the center with the pretty little laser beams coming up. And we've got the Stacks and Aroma campaign that was in the summer of '23 I'll talk to you about in particular. This is a map of the TollNet stations in Los Angeles, Boulder, Colorado. The Rocket is the mobile LiDAR here in Huntsville, and then we have stations at Langley, City College, Hampton. We did have a station in Canada, Amolite, until they lost their funding as a part of that whole COVID shutdown thing. That's an example of several days. I think it's 31 days of continuous ozone LiDAR, ozone and aerosol. All of these LiDARs measure both aerosol backscatter and ozone in the UV during a campaign we had with 5 of the stations at the Table Mountain facility at JPL to look at the consistency. We ended up with about 5% differences, which is really good in the ozone world. This is an example of the Boulder LiDAR that was stationed near Brookhaven. Actually, this is Long Island Sound. It's looking north over the Connecticut land surface and then south over the Long Island Sound water. And it happens to be measuring ozone. It also measures aerosol. And you can see the inhomogeneities, both horizontally and vertically, on the scale of a few kilometers. It's one of the several land water interfaces that we've looked at, including Lake Michigan, Chesapeake Bay, Gulf of Mexico. We have a data site. It's an official NASA data site that houses the TollNet data along with many other NASA data from campaigns, aircraft, and so forth. This is the current generation. We've been doing this for about 15 years now as a network, and there's history prior to that, but the objective, one of the primary objectives was to get a small, relatively autonomous LiDAR that you could operate pretty much anywhere without a lot of expertise. And here it is. This is at the JPL Table Mountain facility. It fits in the back of a pickup truck. You plug it in and it works. It's been deployed several times, and the Koreans actually just put in an order for 10 of them to host over in their peninsula. So we're working on that. Here's an example of, let's see, do we have a pointer? Yeah, okay. So this is carbon monoxide from Tropomi, aerosol optical depth from the NOAA Polar Orbiter. These are basically forest fires in Canada. And then this is measured at City College, New York. This is in Manhattan, where you see the laminar structure from 0 to 6 kilometers over a period of 6 or 8 hours. And you see all of this intense vertical structure here in ozone and down below in aerosols, smoke plumes. These are not always coincident. You can have one without the other. You can have both. You can have neither. In this particular case, the precursors from this forest fire do actually produce ozone, and so you see a lot of synergy between the ozone layer and the smoke layer. This is an example of the rocket laboratory here in Huntsville, where we left Huntsville, in that it's actually housed in that swirl facility where you just heard. We're one of those 5 bays. Thank you very much, Kevin. And we drove from here south to Birmingham. You see the turn at Birmingham and then to Montgomery. This is while the ozone aerosol LiDAR is operating out the top of the truck. And we also had an aircraft flying on the top of it. This is the aircraft in situ measurements that's flying sort of back and forth across the interstate where the truck is going southbound. And we took it all the way to the Gulf of Mexico, south of Mobile, in a place called Dolphin Island. And you can see this happens to be the ozone curtain. The red stuff is high ozone, the blue is low. And the color bars for the airplane are the same. The airplane is also measuring NO2 and aerosol PM 2.5 concentrations in real time. And in addition, we've gotten to the point, I'll show you when we get to the Chicago campaign, that we have real-time communication from the Rocket Mobile Laboratory through the MiFi up to the aircraft and back down. And so the aircraft pilot is seeing the LiDAR measurements in real time in the cockpit and is sending down that's cool stuff, right? You can't even do that in a Challenger, I'll bet. Maybe you can think about that. And we make real-time decisions about where to fly. And we actually did a Seabreeze experiment based on a call from the rocket operator who said, oh, he's got this Doppler LiDAR, Seabreeze is here, fly at this altitude. So we porpoise over the latitude, over the altitude, and got this beautiful Seabreeze effect over Lake Michigan. Okay, this is Dolphin Island. We have ozone here, aerosol there. This is a kind of a movie of the flight path of this aircraft. And here's the LiDAR that was located down here near the airfield on Dolphin Island. And it gives you an example of this is the horizontal variation of ozone and down below in aerosol. And this is all at a pretty low altitude. I think we're flying at maybe half a kilometer. It's an amphibious aircraft. We go all the way to the surface on the water or on the runways. We went to Cortland in anticipation of you folks. This was several years ago. We heard y'all were thinking of coming to Southeast. We said, okay, let's go to Cortland and do a little demonstration so I can show you this slide. I've been waiting 3 years to show you this slide. And here it is. So this is the rocket. This is the mobile laboratory. It's a small truck with a pretty scene of northern Alabama on it. You can see it over there in the, I don't know if you guys are going over there or not, but it's over in the garage. Here's the aircraft. It's a small 2-person amphibious aircraft where there's just simply one pilot and the rest of it's full of instruments and calibration gases and stuff like that. This is the top of the rocket truck with the scanner that's in progress here. And we've done some flights over Cortland at different altitudes. These patterns are actually the size of the Tempo Pixel, which is the geostationary air quality satellite that this was designed to validate along with the LiDAR. So these are basically tempo patterns at different altitudes from, I don't know what the bottom was, pretty low. And the rules are that you can fly right at treetop as long as you're not in a populated area. And I checked it out, and the tower that you guys have is outside the wilderness area. It's in the forest where the 500-foot rule applies. It means you got to be 500 foot from a structure, but that could be horizontal. And you can fly right at treetop all the way to Cortland. So this now provides a transfer measurement from your tower to, anywhere else around the forest, well outside your triangular area of interest. And it could be outfitted with almost any kind of measurement you want. All right, so that's the airplane. Here's another ozone curtain. This is hours across here, up to 8 kilometers, aerosols on the bottom. And this is taken at that Cortland. So this is just kind of a picture of what that, and these are arbitrary flight plans. You can design them any kind of way you want. This is Chicago. Those of you from Argonne will recognize this stuff. These are all of the flights that we did. There were 82 hours over 42 flights. We had 21 days of LiDAR measurements and 180 drone profiles flown out of Chilwaukee Prairie, which is a little tiny wilderness site just south of Kenosha, half a click west of the lakefront. So there's a picture of the rocket there. That's Lake Michigan. There's the airplane. There's the DC-8 flying over the top of us. We were actually a flight of 4. Check this out. I don't know if you got any airplane people. We had a Gulfstream 5, a Gulfstream 3, a DC-8, and a 2-passenger Sea Ray stacked, coordinated with Chicago Center. It was beautiful. This is Gary, Indiana, source of some precursors. This is Chicago, source of some more precursors. She's joking. Polite. So I want you to know, I flew right over the stack of the coking plant. The stack that is about the size of the stage. It doesn't look that big when you're flying over it. So we're doing 1 hertz NO2, and you go over this stack, and it's cooking. The airplane goes zoop, and the NO2 goes zoop. I'm watching this real time next to me, and it was, anyway, so if you want to know what's coming out of that stack, I can tell you. We also flew ship plumes, right? The ships come out of this, so we go fly on the deck. I'm not talking about like 10 feet above the water. We're flying through the ship plume of these ships that are coming out of this port right here. So we can go places the Challenger won't go. It's completely legit too. You just got to have a pilot who's willing to do it. And then we've got a bunch of other measurements. The Doppler wind was really helpful. That was due to Wisconsin DNR helped us with that. And by the way, EPRI, the what does EPRI stand for? The Electric Power Research Institute funded the aircraft flights. There's a lot more story I could tell you about it if you want to hear it. These are the LiDAR measurements from that. These are days, hours and days of 21 days. Ozone up here, aerosols down here. This is a Canadian fire that came in. You can see it's pretty high levels of, this was like the worst aerosol day they had in Wisconsin all summer. And same for ozone. I think we hit 137 ppb of ozone on the deck. That's pretty high. These are the wind roses. When the wind blows from Chicago, the ozone is bad. When the wind blows from the cornfields, the ozone is good. You don't have to have a PhD to figure this out, but we get paid to do that anyway. So these are the drones. Okay, we had 180 drone flights over our 3 weeks there, flown by the students, a little quadcopter with an ozone and a PM25 sensor on it. These guys stayed up. They wanted to do 30-minute flights over a 24-hour period. So they're flying this drone every half an hour for 24 hours. 2, 3 guys, right, stayed up all night doing it, nighttime, daytime, morning. So here it is. This is ozone on the top, PM2.5 on this trace, temperature, humidity, and pressure. But you can see lots of structure in the ozone and the aerosol. This is only in the bottom 100 meters. Okay, this is the size of your tower in Bankhead. This is what it looks like flying with a drone. So now you can think about surface measurements, tower, drone, tether, airplane, satellite. You can fill your observational space with these different assets. Then you bring in the radars and the aerosol instruments. You can do some serious science. Let's see, we've got, so this is ozone in color from 30 to 100 ppb ozone from all these Chicago flights. We also flew around kind of dropping in there are lots of airports around Chicago. You guys may not know that, but there are a lot of airports and we landed at every one of them. And so that's the way we would get vertical profiles, is to go do a touch and go, which means you put the tires on the concrete, run down the runway, and then you take off. So these are all, this is O'Hare up here, midway down there. This is the little airplane over Lake Michigan. This is the NO2, and you notice that it's darker colors down in the source regions. And this is a PM2.5. This black stuff here is that Canadian fire. Here's the important part. We had inside intelligence about this because Brad Pierce from the University of Wisconsin-Madison had run a campaign, Lake Michigan Ozone Study in 2017, where they hired scientific aviation to go fly around measuring the NO2, and they never found it. And Brad said, you know, he's a modeler. He's one of the best modelers in the business for air quality. He says, Mike, I think the NO2, which is the precursor for ozone, is down low over the lake. Now, who would have thought about that, right? That's no source of NO2 over the lake, but it comes out of Gary, Indiana, and Chicago and so forth, and it stays in a plume very low. Now, I'm talking below 100 feet. So I said, okay, Brad, we'll go find it. And so we did. And here, here's, how do I back up like that? Yeah. So here's the profile with the DC-8 spiraling down, you know, measuring 50, 60 kind of ppb of ozone. And they quit at 1,000 feet because of NASA regulations and so forth. And off they go, never did see it. And here's the Sea Ray down here flying, you know, skipping over the waves. And there's the ozone down here. And here it is on the profile. So they quit at 60. We saw the 80, 85, 90. In the PBL, this is only 100 meters down here. And here it is in NO2. This was the payoff, at least in terms of what Dave Fahey, the director of the Earth System Laboratory at the Boulder Lab, thinks for NO2 measurements for the entire Aroma campaign over Chicago. And so here's the DC-8 flying from 5 kilometers all the way down here, measuring 1 ppb of NO2. And this is the plume, 10 ppb of NO2 down here at 100 meters measured by this little Sea Ray airplane. And it's a plume. You can see these are the horizontal gradients. It goes from 10 to 0 in less than a half a kilometer. That's an NO2 plume traveling over Lake Michigan for tens of kilometers, maybe hundreds of kilometers, all the way to Kenosha. This is tempo. Okay, we finally getting tempo data. In fact, we were in Chicago on the first day of tempo observations. And this is 2 weeks after the first day, but this is tempo measuring NO2 columns. And here's the Sea Ray measuring the NO2 off the Lake Michigan. This is Chicago. There's Waukegan, Kenosha, Milwaukee. And we're starting to see some correspondence between the satellite measurements. This is NO2. They also measure formaldehyde, which you might be interested in terms of forest emissions of isoprenes, oxidation, and so forth. Scientists understand that. And so here's my conclusion. We have these assets. The ozone it's accepted as the world standard in measuring ozone profiles. There's no question about that. Everybody loves these LiDARs. We have modeling capability here in both LES and in mesoscale, in larger scale, both in air quality and in convective initiation. We've got this beautiful little aircraft that currently measuring NO2 ozone and met, but can be outfitted for many other instruments. You know, as long as it'll fit in this kind of space, we can do it. And we've been looking into these coastal and sea breezes and other sort of interfaces between the land and the atmosphere, and the process that we've been focusing on air quality. Other UAH investigators have been focusing on the weather aspects of it. And we would love to work with you guys. Thank you very much.
Great, thanks so much. We have time for a question or two. Seeing none, we'll move on to Dr. Nair, who will be talking to us about a supplemental site, or a site containing a variety of different measurements that is to our northeast here.
Well, good afternoon. I'm going to talk about the persistent data collection site. So this is a site that has been set up for collecting atmospheric observations, supporting development of ACDS, that is atmospheric characterization of diagnostic suit. So this is in support of Army research related to laser propagation. So I got three names here myself. Daniel Bitley, who is the site manager, and Dr. Tadasi. So this is a collaboration between UAH and Alabama A&M University. Quick overview of the purpose of the site. So essentially, the site has been established to collect persistent data. So 24 hours, 365 days. And so the purpose of this site is to collect data that can be used for validating numerical model that my group is developing. And the purpose is to develop a hemisphere, about 10-kilometer radius. And what this will provide is essentially optical turbulence information, and also aerosol information, and gas scattering and absorbing information. And the purpose of this is to supply for the laser propagation and developing instrumentation that will go on battlefield systems. And so for this purpose, we need measurements of surface energy budget, boundary layer height, cloud cover, and then vertical profiles of temperature, wind, and water vapor, and then also atmospheric transmission scattering and aerosol measurements, and finally optical turbulence. So initially our goal was so we were trying to site this particular facility, and initially we heard about the DOE site being here, and we were pretty excited about that. And so we talked with Cho Kong and Sean, but the timing didn't really work out. We needed to establish the site right away and get everything going. And so we weren't able to co-locate, and I contacted Dr. Tadasi, and he was really kind enough to set up an agreement between A&M, UAH, and Army SMDC to establish this site at the Winfred Thomas Agricultural Research Station, which is north of Huntsville. And so this is located in suburban land cover. So the site itself, this is a plan of the area where we have all the major instrumentation. So I just want to give a quick overview of the current existing facilities there. So this is a collage of all the instrumentation that we have there. So this is the aerosol suite of instrumentation. So this is designed for being able to be transported to different locations. So the idea being that once we develop the models and validate it for this particular site, we also want to make sure that this works for other sites around the globe. And so this is being designed so that it can be transported to other locations. We have a 10-meter tower with multiple Campbell Scientific sonic anemometers. So the idea being that we want to characterize optical turbulence in the surface layer. And then we have SODAR and RAS, and extend that the optical turbulence measurements further up in the atmosphere. And to go with that, we also have the eddy covariance system. It has all the plane heat, sensible heat, all the streams of radiation, and also soil measurements. This is the interior of the aerosol suite of instrumentation here. So it has size distribution measurements going from about 10 nanometers all the way to about 40 microns. And then we have the black carbon measurements and different transmission measurement systems here. And I also want to point out, we have the SIMO, sun photometer, so we can use the measurements here and kind of propagate it to other locations based on measurements that we make here. And also, we have plans to, so we are collaborating with AFID, that is the Air Force Institute of Technology, and we're in discussions, and it may lead to siting of an MPL instrumentation here. And we also still have some funding to get additional instrumentation. And so if we do get the LiDAR, then we can allocate that funding to other instrumentation. So there is some flexibility to add additional instrumentation. And so a couple of things that we are considering is right now we lack aerosol mass measurement. So it would be good to add that. That's one in consideration. And the other piece of instrumentation that we are hoping to add is aerosol speciation itself. So potential for this site includes, if you want to look at landscape heterogeneity effects, this is sited in a suburban location. So this will pair nicely with the Bankhead site, which is a homogeneous site. And so this is, you can get measurements for heterogeneous site. And so if you can couple this with a couple more energy measurement systems spread around the location, that would actually nicely supplement this site. And one other capability that I want to mention, or actually two other capabilities that I want to mention, is we are putting together a dense network of observations. So essentially it would consist of about 35 to 40 weather stations that can be deployed in the network around the site. And so we are also developing techniques where you can use those measurements and couple that with data assimilation in the model. For example, WRF, you can assimilate that. And maybe that's a cheap way of getting spatial heterogeneity of flux measurements. And one other capability that we've been developing is actually looking at AI models to take weather station information and come up with flux partitioning from that. And it's ongoing development, and it seems to work reasonably well. One other instrumentation that we are developing is fine wire anemometer that we can deploy on a balloon and get profiles of temperature structure function. So essentially, you can use the measurements that you have here to look at coupled evolution of boundary layer and aerosols, and also looking at line cover impacts on clouds. So we recently submitted a proposal kind of looking at some of these ideas to the recent call in collaboration with Alabama A&M. So I think that's all I got, and I can take any questions that you may have.
Any questions?
Thank you. Very interesting talk. Exciting pairing with the potential main tower site in the Bankhead and this indeed. You mentioned AI to partition fluxes. Are you talking about carbon fluxes or water fluxes, latent heat fluxes, partitioning in ET?
Essentially sensible and latent heat flux. So the idea being that if you can get a model to kind of match the evolution of temperature and humidity in a weather station, you can
estimate,
get the partitioning, yeah.
Any other questions? Okay.
Thank you.
Seeing none. All right, up next is Dr. Sean Hooley, who's a professor in the Atmospheric and Earth Science Department, to talk about her aerosol lab.
Hi, everyone. Welcome to Huntsville. It's nice to see friends and collaborators and colleagues. So I want to show you some of the research capabilities that we have in atmospheric chemistry group. So currently we have projects focused on new particle formation. New particle formation is one of the scientific focal points, as Chonggai will explain a lot this afternoon, hopefully. So we have new particle formation projects classified field campaign and the laboratory studies. So in the laboratory studies, we study kinetics of new particle formation, of biogenic new particle formation under the influence of pollutant. So that is very relevant to BNF new particle formation process. And then we also study new particle formation during the prescribed forest fires at University of Georgia Fire Lab. So that is funded by DOD recently. And then we also do field campaigns of new particle formation. For example, we do urban new particle formation studies in Houston, starting from 2022, and we are going to do second IOP in January 2025. And additionally, we also make long-term measurements of new particle formation in Swirl. Preston just explained the facilities there. So that started from 2016. So if you are interested in comparing, BNF very pristine or relatively pristine environments with, similar climatology, but with more pollutant presence in Huntsville, we can collaborate for those kind of, work. So, okay. Thank you. There's green pop, I'm sorry. Oh, okay. Shows my age. So here is the photo of my lab. Welcome to visit my lab if you have time tomorrow or if you stay along. And we have instrumentation focusing on the measuring of new particle formation precursors in the gas phase, as well as the aerosol size distribution and a very detailed chemical speciation of aerosol particles. So, for example, here shown in this setup is the laboratory experimental setup with the flow tube. But you can see here first the sulfuric acid seams that can measure down to 10 to 5 molecules per cubic centimeter. So if you do aerosol science, you know that sulfuric acid is the most important precursor for new particle formation. You have to measure sulfuric acid regardless you are in forest or if you are in Arctic or Antarctic or urban environment. So, and then ammonia seams can also measure ammonia and amines down to sub-ppt level, and the ammonia amines are also very coupled with sulfuric acid because of acid-base reaction, are very important nucleation precursors. So, and then we also have this high-resolution time-of-flight chemical ionization mass spectrometer seams that can measure oxidized organic molecules, and which is very important for the growth of new particles from the nucleated sizes to the cloud condensation nuclei, and also important for the nucleation as well for some under some specific conditions. I will show you some of those examples. So this HRTOF seams, we can use 3 different modes. For example, when we use the iodide chemical ionization with Figaro, we can measure gas phase and the particle phase oxygenated organic compounds simultaneously. And also this instrument can be used with nitrate ionization, and we can measure chemical gas phase clusters containing sulfuric acid, ammonia, and amines, and oxygenated organic molecules, especially highly oxygenated organic molecules, extremely important for new particle formation as well. And then these instruments can be also used as epitope, and that can measure atmospherically formed, naturally occurring ion clusters, which can be also important for new particle formation. And then we also have a particle size magnifier and SMPS. Those together can measure aerosol sizes between 1 to around 1,000 nanometer. And then we also have this maybe it's difficult to see, but behind that counter, we have also ultra performance liquid chromatography, electrospray ionization, Orbitrap high resolution mass spectrometer. So this has extremely high resolution, like 150,000 mg the unit. And that can be almost 2 to 3 orders magnitude higher resolutions than this high resolution time of flight seems. With that, we can identify chemical formula, and also with the liquid chromatography and tandem MS analysis, we can infer the molecular structure of very complex oxygenated organic molecules. So those instruments are currently used in the laboratory studies, but they are all also, except these offline LC instruments, they are deployable. For example, during the tracer, the IOP 2022, we were funded by NSF, but we brought these instruments to the University of Houston campus, and we did measurements of ammonia and aerosol size distributions and sulfuric acid and gas phase and particle phase wounds. So I'm going to show you some of those results. Actually, I was thinking, looking at art, we used the sulfuric acid in 2009, long time ago in Brookhaven National Lab for the aerosol life cycle IOP. Yes, life cycle IOP. I already forgot that. Yes, so, and then this instrument has been also used, the sulfuric acid systems and ammonia systems have been used in SOS field campaign in 2013, a long time ago already, in Centreville where we found the isoprene can suppress new particle formation. So that will be also very relevant research, in terms of new particle formation in Brookhaven, not the Brookhaven, BNF, Bankhead National Forest. So So I just wanted to show you the capability. Sean told me that I should not talk about the science, but I think it's impossible to talk about science, talk about the instrument capability without science, right? So this is a very neat mass spectrometer. If you're not a chemist, don't worry. It's not very true. It's not important. But what I like to show you is the gas phase during the laboratory experiments of alpha-pinene ozonolysis, which can take place in BNF as well. And we simulate this process, we can see gas phase wombs. So here we can see, here is the, oh, wonderful. So here is monomer of alpha-pinene oxidation compounds. And then here is dimer in the gas phase. This is measured by iodide seams. And simultaneously, when we look at the particle phase wombs, we can see there are more dimers than monomers relatively if you compare to the gas phase. This is because dimers are much more sticky, much more low volatility, so they tend to be in the particle phase. But the interesting thing is if we compare these online measurements with offline measurements of this high resolution mass spectrometer, they show strikingly similar properties, the same features. And as I mentioned, because of this high resolution mass spectrometer, very, very high, very high resolution, and also MS, the capabilities, we can also identify these different molecules, their structures, as well as the chemical formation process, and we can also identify isomers, which is important in order to predict new particle formation process very, chemically constrained, using chemically constrained model. So I want to show you some of very preliminary results or unpublished results. So this we got very recently, just before the AAAR. And I'm showing you this because I want you to, when you do new particle formation in BNF, you may want to focus on organosulfate. So what we did is we tried to simulate this alpha-pinene ozonolysis new particle formation processes. So this is nitrate seams. You can see in gas phase, you can see monomer, dimer, as well as trimer, because nitrate seams can measure oxidized organic compounds much more efficiently than iodide seams. So this is a pure alpha-pinene ozone system, but then as soon as we added SO2 sulfur dioxide, so this can be transported. And in our laboratory experiments, we can see the trimers disappearing, but at the same time, we see lots of oxygenated organic sulfates. This is a gas phase, very interesting. And very interesting, we found that when we have this sulfur dioxide, nucleation rate is increased along with this enhanced organic, oxygenated organic sulfates. So we think maybe oxygenated organic sulfate is important nucleation precursor, which never considered before. This is a secret. I'm just telling you in this room. So, so how do we know this is organosulfate? So now we can use this liquid chromatography analysis. We can see with this liquid chromatogram, we can see this is definitely organosulfate, and MS analysis shows that very distinctive signature of sulfate. So we know this compound. So what I'm thinking is there are two possibilities. One is the organosulfate formed directly in the gas phase, for example, SO3 with organic, carboxylic functional groups of WOMS, or this organic sulfate forms in the particle phase, but they are semi-volatile, so they can be evaporated from the particle phase and goes to the gas phase. Regardless, they are correlated with enhanced new particle formation. So these are the laboratory studies. It's very, very relevant to the BNF new particle formation studies, but I also wanted to show you the capability of field campaign of these instruments. So this was during the tracer IOP. We just caught very 2 weeks of September last week. And then we extended another 4 weeks in October 2022. And we did measurements and we found very distinctively different concentrations of alkyl nucleation precursors, for example, sulfuric acid, and the SO2 is a precursor of sulfuric acid. And sulfuric acid is a precursor of new particle formation. And the ammonia and amines, they are very important nucleation precursors. And as well as low volatility and extremely low volatility of WOMS enhanced during the higher concentration during the new particle formation events compared to the non-events. So this is very interesting in a way because from early 2000, from the NOAA field campaign, Chuck Brock, for example, mentioned that in Texas, in Houston, especially new particle formation always is sulfur driving. But to my knowledge, this is the first time we measured very accurately sulfuric acid concentrations in the gas phase. So it is very reliable instruments. And we also measured this ammonia and the WOMS. And with these precursors, we did a closure of nucleation rate and the growth rate using the current nucleation parameterization provided by CERN cloud chamber experiments. They do fancy, very expensive measurements, and they provide very updated parameterization. And if you look at those results, interestingly, using our precursor concentration, sulfuric acid, amines, and WOMS, we can predict the measured nucleation rate is very neat. So this is the first time nucleation rate in urban sites is made closer with the measured precursors. Not only nucleation rates, we can also predict the growth rates from these nucleation precursors, and you can see WOMS are important for nucleation as well as growth rates. So furthermore, using this WOMS, we also did a PMF analysis. So this is very recent results. We just got these results actually this week. But it is very exciting because using this kind of analysis, we can identify source of WOMS, for example, whether it come from traffic, also coming from, it is biogenic oxidation, biogenic VOC oxidation or anthropogenic VOC oxidation, or they formed during the day or during the night, etc. So this will help to understand the formation process of WOMS and therefore the contribution to the new particle formation. I think it's similar, this kind of features can be also predicted in BNF. So with that, I'm open for any collaborations if you're interested. So thank you so much.
Any questions?
I understand it's too much chemistry, right? We like lighter.
Well, thank you. Dr. Lee will be around. You can ask her questions after. Last but not least, we have Dr. Philip Bitzer, who is going to be associate professor in the Department of Atmospheric and Earth Science. He'll be talking to us about his group's lightning instrumentation.
And after this, we'll do a 10-minute break, and then we'll start in with the site science team.
Well, I'll get us to that break pretty quick then. Hey, welcome everybody. Welcome to UAH and Huntsville in general. I'm Philip Bitzer. I'm a professor here at UAH, focusing mostly on lightning. So talk to you a little bit about some of the facilities that we have here that can help play a role in some of the great work y'all are going to be doing down at Bankhead. So, at UAH, we have instrumentation facilities to handle studying lightning from the ground to the air and even to space as well. And we do this sort of research with these instruments, both developing the instrumentation in the lab, doing sort of basic science research, and then sort of some of the applications. Understanding how lightning and severe weather, how that interplay goes, and some other work that we've done looked at how identifying the types of lightning that lead to wildfires and pulling that out. So those sort of application sort of things that we really are interested in. So just a hodgepodge of pictures for you guys. Hey, I got it right. So I really want to talk about two main things that we've been doing here that would, I think, really help what you guys are trying to do as well. And one is what we call the lightning mapping array. It's really good for making maps of lightning, detecting total lightning flashes, things of that nature. It works in a very high frequency domain. We have other instruments on the ground as well that are wideband, that work in a different frequency domain, that are really good at seeing things that come to ground, like strikes to trees and things like that, which we're really interested in when we're studying forests. And there's other instrumentation as well, both here at Swirl and across at NCC as well. Cameras, spectrometers, which are really good at seeing temperatures and how the temperatures affect when it strikes a tree. Mills, satellites, and other various entities. Just a couple of pictures of the instruments that we use that are on the ground. A fairly small footprint. Up top is an example of an LMA antenna. I should mention that both of these are passive antennas as well, in case that's something that you're interested in. Excuse me. I always say that the bottom one, which is the sort of wider band, lower frequency sensor, is more like an AM radio. It's like a really fancy AM radio. If you're ever driving through the Midwest, you can hear crackles on your AM dial. Does anybody listen to AM radio anymore? So it's these two instruments I really want to focus on. And they provide that maps that look like this, and sort of really focus in on the sort of this figure here. And you kind of very clearly see when we produce this lightning, there's all sorts of electrical activity in the cloud, but we're really focusing for forest studies is what's coming to ground and where it comes to ground. You can see from this map, it's very clear where it comes to ground. The red line, it actually traces out a couple times. You see that red spot, that's where it's coming to ground. And this particular lightning flash produced, I think, 7 different return strokes straight to ground. So just one lightning thing can actually produce multiple ground contact points. This one happened to create 1. But we can use these sort of data to really study forest dynamics. And it's something we've been doing quite a bit down in Panama. We've had a long-term study down in Panama studying the effect of lightning on tropical forests down there. If you've ever been down there, you know the Barrow, Colorado Institute that's in Panama. It's a Smithsonian Institute. It's well protected. We studied there for, I think it was 4 years, to really study a really small area to understand how we do this. And then now we've expanded out to basically the country of Panama. And on the left is a screenshot of one of the cameras that we have down there to help identify the trees. I like this one because it kind of looks like a cool lightning strike. And you can very clearly see where it's striking the tree. With a series of cameras and those other ground-based sensors, we can identify which tree actually got struck, and then study how the forest responds to how that tree how the forest responds to how the lightning responds to the tree. In the lower left, or I guess the middle left, is a screenshot from a drone video. So we identified this tree got hit. We sent the drone out to identify any damage that was around. And this drone video, I think, was taken 2 weeks after. You can kind of see part of it's dying back, and some of the crowns are completely intact. And we've been able to take data like this over many, many years and start to come up with sort of conceptual models of how the forest dynamics are changing. And one thing that I've been able to identify is that there are certain species of trees that seem to be more resilient to lightning strikes. In other words, lightning strikes these trees and there's no damage, whether it's the next day, 2 weeks later, 2 months later, 2 years later. It just seems fine. It took the hit and kept on going. And there's other trees that die back completely, sometimes the next day, sometimes 2 weeks later, sometimes 2 months later, sometimes 2 years later. And so we've been able to see how the forest is changing because of how lightning is affecting these particular trees and these particular species. And this is sort of a hodgepodge of some of the notable research that's come out of this project, particularly studying how lightning is affecting these forest dynamics. A lot of the work we've done has been done in Panama, but we've done work elsewhere as well. The picture on the left-hand side, I think, is from Argentina when we did a project down there as well. And you can see on the right, sometimes when you're working in forest, sometimes you've got to climb towers to put your instruments up there, and that's exactly what we're doing. We've also done a study in the temperate forest, and so that was a little while ago, and we weren't able to do sort of the detailed studies. So we're really eager to collaborate with you guys and what y'all are doing down at Bankhead, and to really understand what's going on with forest dynamics in another place, another part of the world. So by all means, please come find me. Let's talk. Let's try to find out more about lightning and forests. Thank you.
Questions?
Okay, everyone. Number one, I'm so stoked and excited to see everyone here gathered after what feels like a 5-year long nap. So stoked, so excited. So yes, I'll be kind of introducing our site science team. some of our science drivers, some of the science work that our team has been doing. So really wanted to highlight contributions from Scott Giangrande from Brookhaven National Laboratory and Sean Serbin from NASA Goddard, who kind of form our core leadership team for this deployment. So just really quickly wanted to thank the Seans, Sean Serbin on the left and Sean Freeman from Huntsville. So Sean, again, member of our site science team leadership, and then Sean Freeman, ASR funded PI, doing BNF related work. I thank them for their generosity, for making themselves so available to the media during the media day yesterday. The QR code got blocked a little bit, but definitely happy to point you to that interview that broadcast last night on Fox. So thank you, Sean's. So one aspect of our deployment that we really wanted to emphasize and clarify, and I'm so pleased to hear it, right, during these presentations, was that our science really is looking from, the surface and, quite frankly, the subsurface to the canopy and all the way to the clouds. And this is a photo that Sean Serbin took from the fire tower that those who are going on the tour tomorrow are going to see. I don't think you can climb the fire tower. But we took opportunity when we found it just to kind of give you a sense of what the terrain, the canopy cover looks like, and some of the clouds look like over the Bankhead National Forest. So really, this is a campaign that emphasizes scale. By scale, I mean we're looking at things not only at the canopy scale. So this is a LiDAR-derived canopy elevation map over the main site and kind of showing you where the tower location is, up to scales encompassing the northern Alabama region, as well as our larger site and facilities. So kind of showing you the Bankhead Forest with our 3 supplemental sites, all the way up to the larger southeastern United States. And it was really great to hear the overview that Beth gave from her Solar Workshop report, talking about some of the unique aspects and challenges that are impacting the southeastern United States. So what I wanted to do first was to give a big shout out and thank you to our site science team. So the upper photo shows we were gathered at Brookhaven for our site science team workshop. And then also our partners from Argonne with their site operations. So really talking about Mike, Nikki, Patty, and Mark Spicella. So those from our site science team who are here, and also from our Argonne site operations team, can you please stand up and let's give them all a round of applause, please. I often get the question, Shanghai, would you do this again if you had the chance? But I answer a different question. I say, if I had to do it again, I want to do it with the same people, right? The exact same. So the lower image on the right is an image from inside. I think it's a laundry room inside. Someone's gonna have to help me out where this is, but this was done during a tornado warning, right? So this was done during a site visit where the threats are real, the impacts are real, but in rain, storm, hail, shine, the site operations team and Sean were very diligent in going out to the region, learning what they can on the ground, and also helping out too. So again, here's our core site science team. So members of the site science team that are here include Jim Smith, Allison Steiner, who's online, Greg Elsasser, right? And so if you want to talk with members of the site science team, I encourage you to do so, especially as we go. If you're curious about the history of why we're here and how we got here ourselves, and if you're wondering why we're all smiling, it's because we were probably a little bit naive before we embarked on this enterprise. And I would say that naivete was not only present, but actually kind of necessary for us to kind of undertake this enterprise in the way we did, given the scope of what we were hoping to achieve. So this diagram, some of you may have seen, but I wanted to present to you just some examples of the science drivers that our science team envisioned when we first were kind of designing the concept for this deployment. And so there's science related to convection in the top, aerosol processes in the middle, and I think very critically for this campaign and for this audience, science drivers related to land-atmosphere two-way interactions. And if you think the science looks broad and kind of a lot, you're right. Right? This is science that no one science team is meant to be able to achieve or to really close, but is really meant to show you what the community can investigate, look at, and really feel that, for this site, there really won't be any such thing as, oh, everyone discovered it all already, right? There's plenty of new things to discover, plenty of new collaborators to meet, right? Especially in the arrows that cross-cut across these different disciplines. I won't get into too much here, but our science team took all these science drivers, translated them into sighting criteria, then into maps, and that's how we did our initial search and select down for where to go in the southeastern United States. And we can certainly chat more about that later. So this is some pretty fresh aerosol size distribution data taken from the site. And Shanu, thank you for introducing new particle formation within your talk. So this is an observation of new particle formation taken at the main site. So what we see is a size distribution plot where the vertical axis is aerosol size. So here are the bigger particles, here are the smaller particles. This is UTC time, and then color intensity is concentration. So right around 15 or 16 UTC, we see these sudden bursts of really small particles that then grow up to larger sizes. And the reason why I like to show this are twofold. One, it's kind of like a dream come true, although I really shouldn't use using the word dream because number one, I should have better dreams, right? But number two, we didn't know what we were gonna measure when we came to this site. And so it was with somewhat of a hope and a prayer of, hey, trust us, we are setting up a site where you can study these processes. And so to see it was very relieving. And the second reason why I'm showing this is because I think this is a great example of the coupling between the terrestrial ecosystem and the cloud life cycle. The reason I say that is because these small particles form from gases that are emitted from vegetation. So there's one connection to the ecosystem. Then these particles grow until they can become large enough to scatter light and then also become possible cloud droplets, and that's your second connection. So this won't be the only one that connects across these disciplines, but something that we were really excited to see so early in the start of the campaign. I wanted to highlight, with respect to kind of looking forward, a ficus project. So this ficus concept was that Nikki introduced earlier, this collaboration between the ARM user facility and the EMSL user facility, where, along with my team, so Sean Serbin, Tamana Suba, and Maria Zavadovich, we're going to be leveraging the tethered balloon platform to study one aspect of how the forest and the boundary layer controls new particle formation above in the atmosphere above the forest. So here just showing a schematic of precursors being emitted, mixing in, forming a residual layer, then reacting possibly a day later to form particles that are then transported downward. And so this was kind of our proposal, and our first set of flights are proposed to happen in March. So again, kind of letting folks know that as campaigns are being planned and approved, we are working hard to build a timeline so everyone can understand who is approved to deploy and when to better coordinate resources to enhance co-location and co-deployment. This is an example of an instrument that we will be deploying on the TBS. So this is a little condensation particle counter that we've been working with a small business to extend its measuring capabilities down to 1 nanometer. And the reason we're using this system is because it fits on a TBS payload, right? We're limited in space, we're limited in weight. And so with a system like this, we initially deployed to another ARM fixed site. This is at the Southern Great Plains. There's a tethered balloon. This is the tether, and then here are the instruments along it. And if you can look really closely, we are being impacted by a biomass burning plume, right, at the Southern Great Plains. And during that deployment, we made observations of particle number. So at the surface, very low particle number concentrations in the really small size range. But then as we ascend, we encounter this layer of elevated small particle number concentration, right? And then as we descend in the TBS, the concentration goes back down to 0. So we're going to be testing some of the hypotheses derived from these observations of the Southern Great Plains over the Bankhead National Forest to see if we also see this type of vertical structure in new particle formation at the site. And I think the last slide I want to show is some of the work we're doing with respect to modeling at the BNF. So here again is a map of the BNF showing the 3 supplemental sites, S20, S30, S40. With a colleague, we ran some WRF-Chem simulations. So just a weather forecasting model with some aerosol chemistry, just to get a sense of what does aerosol spatial variability look like in the domain in the month of August. And so what we're plotting here are essentially 3 plots of number concentration over the time period, normalized to the main site. Right? So if you see data close to the line 1, that means that the supplemental sites are basically seeing what the main site is seeing. And when you're seeing excursions from one, that's where we're really being impacted maybe by advection into the domain or by really local sources. And the reason that I asked our colleague to do this was, okay, we know that models aren't perfect and they often aren't right, but can we use modeled variability to tell us where to put our aerosol sensors, right? And these aerosol sensors are the design is being led by ARM to put size distribution sensors at 2 of these supplemental sites. So I mentioned this to just give an example of what a kind of MODEX is, in the sense of we're not really using the observations to fix the model, but really using the model to tell us where to make strategic observations. And so at this point, what I want to do is transition to our site science team member, Allison Steiner, who's online, who will be kind of continuing a presentation talking about aerosol spatial variability and other exciting science drivers within the region.
Apologies that I am not able to be in there in person. I'm extremely disappointed, actually heartbroken not to be there, because as Changai mentioned, we've been working on this project for almost 5 years, and I'm really excited to see the site in place. So to pick up with where Changai left off, he showed the diagram of how we've been thinking about the site science plan, and I'm going to focus on some of the orange pathways about trying to understand emissions from the biosphere and how they can feedback and connect with clouds and other atmospheric processes. And so one of the questions that we've been talking about, or trying to understand these temporal and spatial controls, especially the ones that Changai just mentioned, on aerosol climate impacts, and aerosol climate feedbacks within the domain. And so one thing to frame it with, we've heard a little bit about this, I think, earlier today. We know from prior studies that organic aerosol is a really important component in the southeastern US. And so we've heard a little bit about new particle formation, and from Sean Hu, a little bit about organosulfates. And so here I'm showing the Megan biogenic isoprene emission factors, which we use to predict biogenic VOCs from the model, as well as a pie chart of some of the composition from the SOAS 2013 observations, showing a really large fraction of this aerosol in Centerville, which was a site to the south of the Bankhead site, was comprised of organic aerosols. And so one of the questions that we've been talking about, the science team, is trying to understand these temporal and spatial controls. And so how do we understand, especially as we think about feedbacks between the surface and the atmosphere, or feedbacks between aerosols and clouds, how do we understand within the atmospheric boundary layer what aerosols might be locally formed, meaning if we have local emissions of isoprene or monoterpenes coming off of a forest, how they might be producing organic aerosol directly above, and how much of that aerosol coming in would be non-local formation, or this advective contribution that Changai was just talking about. And so we've been, one of the opportunities of the site is that now we're going to have continuous aerosol observations over long term, and that can help us understand a little bit, but models can still be helpful in terms of interpreting where the aerosol might be coming from also, whether it's a local formation or something advective. So one way we can try to disentangle this with models is by using a one-dimensional canopy modeling technique we've been using in my research group to quantify what the local contribution might be. And then we can, from the advective contribution, we can use 3D models like WRF-Chem to potentially understand how aerosols might be advected into or out of the region. And so when we've started to do this for looking over the Bankhead National Forest site, we've been calculating local organic aerosol formation rates using this one-dimensional modeling approach. On the left, I'm showing you a two-day time series, and looking at the change in organic aerosol integrated above a forest canopy coming from either isoprene organic aerosol production or monoterpene organic aerosol production. And looking at those two lines, you can see that the isoprene production is a lot more variable than the monoterpenes. Even within the 1D model, the monoterpene emissions and formation rates tend to be a little bit more constant. And that allows us to actually quantify how much mass we could be producing absent any advective changes. And then we can also use WRF-Chem models, and this is showing a sample simulation in the upper right-hand figure with the Bankhead site starred in shown in the star, and using a sort of divergence approach and using a Green's theorem with the model, we can actually calculate the advective component of how much organic aerosol is being advected into or out of that yellow box surrounding the site. And so we did this for a test simulation over June. I'm showing you biogenic aerosol here on the left and total secondary organic aerosol on the right. And the top is over a 1-week simulation period, and the bottom panel is an average diurnal cycle for both of those. We generally can see that the model is simulating much more divergence, which means that whatever you might be producing within the box is going out of the box. So we don't see under this case that we see a lot of incoming aerosol. That advective component tends to be strong. However, you can see in the full time series that there's a lot of episodic ups and downs, meaning that there are time periods when we might be more likely to have advective conditions than others, and that can tell us things about how we interpret the observations. The second thing we've been thinking about is the aerosol climatic impacts and looking at primary biological aerosols as well. And so, as we all know, modeling frameworks can be useful for trying to understand and connect surface observations with what's happening aloft with clouds. And so we can also use 3D models to try to assess that as well. And so also providing an example from the ARM Southern Great Plains site, we had done some work at the University of Michigan trying to understand the impacts of pollen as a bioaerosol on cloud formation, including both warm cloud formation and ice cloud formation. So this is showing model simulations over Oklahoma with the SGP centered right there. And this is simulations from pollen, where we see a lot of emissions from pollen in the trees a little bit to the right of the SGP. And then we also can use the model to understand and investigate how changing different parts of the model parameterization, and especially how pollen can act as an ice nucleator, can impact cloud vertical profiles. And so these are showing you changes in ice water content as we start to modify different parameterizations of pollen and the rupture and pollen fragments within the atmosphere. So this new site at Bankhead is allowing us the opportunity to do the same kind of study with aerosol and cloud properties, linking the models and observations, in a new framework over a forested ecosystem, which I think will provide some new and interesting ways of thinking about this. To connect it to other DOE facilities that we've been working with, this is showing some work from a prior FICUS proposal that I had with Swarup China, who I think you're going to be hearing about a little bit later, where we've been looking at how pollen can be nucleating ice, the same as the example I showed over the SGP. And so Swarup has been developing and looking at ice nucleation rates, and we've actually been looking at 3 different types of pollen based on samples we've collected in Michigan for birch, oak, and pine. And looking at how they vary in terms of their ice nucleating potential. And some of the work that Swarup has been working on is showing that we actually can see variability in the ice nucleating potential of these pollen fragments for different types. And then we can test that within model frameworks. So this is another simulation of WRF Chem from the southeastern US, where we actually can test the impacts of different types of pollen on ice nucleating clouds in the region. And so this is showing you just some time series this is output from the model. These are 2 days in time during a convective event that I'm showing here in this panel. And we can see the formation of clouds, roughly from the order of about 2 to about 10 kilometers. This is the ice water mass shown on the top and the liquid water mass on the right. And these are perturbations to the ice and the liquid water mass once we allow different types of pollen to influence the cloud properties. And so this is the kind of information that we're hoping with observations, we can get a little bit more information about how these simulations are performing and whether or not we can see these types of feedbacks between the land and the atmosphere. So looking forward, I think one really important thing we've talked about as a science team, and we're hoping that we'll gain a lot of interest within the community there, is about the role of biogenic VOC is going to be really important in terms of understanding organic aerosol formation and their feedbacks. One other interesting thing that I didn't touch on today that is, looking at differences between isoprene-driven OA versus monoterpene-driven OA, and also looking at biological aerosol particles. They're very unconstrained in this region right now. We're very limited by those types of samples, and we're hoping to see some of that at the site as well as getting into some of these questions of horizontal heterogeneity. These supplemental sites that Changai mentioned can be helpful in terms of how we do that sort of advection analysis that I mentioned, as well as vertical heterogeneity and the role of vertical aerosol gradients for cloud processing, which can be from the chemistry perspective, as well as cloud formation and CCN. So thank you very much, and I'd be happy to take any questions if we have time.
I'm going to be talking about the IMPROVE program. This is a program that does PM 2.5 chemical speciation monitoring, and we have been doing it at the Bankhead site for decades, but it's also a national program. So I'm going to start big and then move into the particulars at Bankhead. So the IMPROVE program, that stands for Interagency Monitoring of Protected Visual Environments. It is a cooperative effort between multiple federal organizations. It started in 1988 with about 30 sites. And the idea of it is focused on class one areas and the regional haze rule, which is part of the Clean Air Act. And so the regional haze rule requires this monitoring at national parks, wilderness areas, and the like around the US. And in around 2000, we went from 30 sites up to 165 sites. So we cover almost every national park and wilderness area and many national monuments with these improved monitors. The UC Davis, where I'm located, has been operating the improved program for the National Park Service since the beginning. This picture that you're seeing here is at Yosemite National Park. And you'll see there's there's 5 stacks, 4 that look the same, and then a 5th one with a different inlet on it. And on the inside of this little wooden structure, there are individual samplers with pumps attached to each one. And in each of the samplers, there are filter cartridges. So we collect filters and on a 24-hour basis. And the smokestack the inlet stack that looks different is PM10, but all the rest are PM 2.5. All the speciation is done on PM 2.5. So here's a graphic of what that sampler looks like. We sample 24 hours, midnight to midnight, local time, every 1 and 3 days at about 23 liters per minute. So that's a fairly high flow rate. Our filter size is just 25 millimeters, so they're fairly small particles. And we do that because we're in national parks and other places with low concentrations. So we want to get the areal density on the filter as high as possible. We use 3 different kinds of filters. The first one is a Teflon filter. We use that to measure mass, and we weigh our filters in a temperature and relative humidity controlled chamber using a microbalance. Then we use XRF, X-ray fluorescence, to measure elements. We have an in-house instrument that I'll talk about a little bit more later, but it measures light absorption of the particles on those filters. And then we also archive these filters so they can be used by others at a later date if we need to reanalyze them or if other researchers would like to analyze them. The second type of filter is a nylon filter. This is for ion chromatography, and we measure sulfate, nitrate, chloride, among a few other things. This filter is destroyed in this process, so it's not archived, although the extracts are available for a few months, but they start growing things after that amount of time, and so we can't keep them very long. So it's not a very long archive. And then the third type of filter is a quartz filter. This we use for traditional OC and EC measurements using thermal optical reflectance. These filters, we only need a small part of the filter to do this analysis, and the rest of those filters are archived, so those can also be used by other researchers. Here's a map of both IMPROVE and CSN. CSN is the urban equivalent to the IMPROVE network. The blue dots are IMPROVE, and you'll see I have a green box around the Bankhead site. We also have an IMPROVE site and a CSN site in Birmingham. So even though IMPROVE is a rural network, we do have a few urban sites, and that is to do comparisons with our sister network, CSN. UC Davis also operates, or doesn't operate, but does the filter analysis for much of CSN as well as for IMPROVE. And then this is a map also showing the entire IMPROVE network. For one element, this is sulfur, and each site has its own time series of sulfur concentrations beginning in 1988, if there was data there, up to current. And you can see, as we all know, in the eastern US, the sulfur and the sulfate have gone down dramatically in recent years, whereas in the Western US, the sulfur stayed pretty constant. It was always fairly low, and it has remained low. So this is the kind of representation or presentation that you can make using improved data looking across the whole US. But what we're interested in is the Bankhead site in Alabama. We call this site the SIPSI site, and thanks to Andy, our local US Forest Service person who gave the talk earlier, I understand what the difference between SIPSI and Bankhead is. So Improve is right, the sampler is has been in operation since March of 1992. So we have data from the Bankhead site every 3 days, or organic carbon, elemental carbon, all that stuff I just talked about, since 1992. This figure on the left shows how the PM2.5 mass concentration has decreased over that time quite dramatically. And for those of you who are going to the site tomorrow, and I'm very envious of you getting to see the site, this is what it looked like for its first 20 years of life, or 30 years of life, I guess, before DOE and ARM decided to turn it into a really exciting, multifaceted monitoring site. So at the Bankhead site, one of the things we can see is what I showed more broadly for all the sites is this incredible decrease in sulfur over time. So again, the site started in 1992, and this is every measurement we've made at that site for sulfur through to nearly current. And so you can see this dramatic change in sulfur. However, for organics, which is really something that we're quite interested in, lots of us are quite interested in, you can see that the concentrations haven't changed, maybe decreased a little bit, but haven't changed very much over the same time period. You can also see a few really high spikes. Those were likely fires, and probably some of the fires that Andy was talking about with the prescribed burns probably hit the site on occasion. And I'm guessing there were also some just wildfires that we're seeing. So the UC Davis program that runs the Improved Network is called the Air Quality Research Center. And so we are researchers as well as staff who are involved in research related to Improve and CSN and all things really aerosol. Some of the things we've been working on is designing new sampling technology. We also work on advancing laboratory analysis, and I'm going to talk about two of those in the following two slides. Developing new methods, comparing, evaluating, developing MDLs, thinking about data quality for all these different methods that we use. And then we also develop and sell standard reference materials for elemental analysis. And for organics, we develop them, although we're not currently selling them, but I'm happy to talk to anybody who's interested in that. And then we've also made advances in data quality, understanding things like I've mentioned, data limits and uncertainties, and some fabulous data validation techniques and data visualization techniques and tools that are readily available to anybody who's interested. And as I mentioned briefly before when I was talking about the different types of filters, other researchers can request those filters for your own analysis. The Improved Steering Committee, who is made up of members of the different national federal agencies that operate Improve, approve those requests. But you can contact me and I can help you make that request. I know all those folks, and especially if it's non-destructive, it's really easy. They'll probably for sure let you do it. If it's a destructive technique, we'd need to have more information, but we're really eager to use these samples that right now they're just sitting in storage. And so it'd be really great to have them used for additional research. So the two techniques I wanted to talk about briefly is one that we developed in-house years ago. It's a hybrid integrating plate and sphere method, which measures light absorption by the particles on the filter. So this is the Teflon filter that we collect, and we run it through our HIPS system. There's a graphic of the HIPS analysis below. And so we developed, this was way before my time, in 1988, developed this instrument. But more recently, in the last 5 years, we've been developing an automated multi-wavelength absorption instrument, which is pictured on the right. And it will be implemented in 2025. So the samples at Bankhead will have this multi-wavelength HIPS used on them starting in samples collected in 2025. And then my particular research interest is on measuring functional groups. So understanding better the composition of the organics. And I do that using FTIR analysis, again on the Teflon filters. And I began doing this for the entire improved network in 2015. So we have spectra going back to 2015 for the Bankhead site. It's a non-destructive technique, but we don't report the data. It's not a routine analysis. It's still more research focused. On the right, you see 3 spectra. I chose spectra from Fresno out here in California because there's a lot of aerosol, and so it's much easier to see what's going on. But you can see the x-axis is the wave number. For some reason, infrared people plot wave number instead of wavelength. And the y-axis is a measure of absorption. And going from left to right, we can see alcohol absorption, carboxylic acid absorption. We also see inorganics like ammonium and then aliphatic CH. And then there's a region of the spectrum that's not very active for things that we care about, although CO2 is very active in that region. But I scrub that out of the air before I take these spectra, so we don't see the CO2. And then carbonyl, amines, more ammonium, nitrate, and then we also see sulfate and organosulfates on the far right. So I've listed the main functional groups we measure. We're working on organosulfates. I know that's important for this site. And then I have another project with the Ascent network. That's another network of 12 sites using high time resolution measurements. Many of the Ascent sites are located at improved sites or CSN sites. And I have a special project looking at trying to take the ACSM measurements and in addition to getting MOA and all the different wonderful things that we can get from an ACSM or an AMS, also trying to get functional group measurements using parallel FTIR data as our calibration set. So if you want to use this data, you don't need to ask me or anybody else. It's publicly available and has been since the beginning. This is the link to the website. And I'm also just showing the landing page for the Federal Land Manager Environmental Database. It has improved and other network data here. And there's also a lot of visualizations that you can just click on the visibility tool, click on SIPSI, which is what Improve calls it. You won't find Bankhead in our list. That's not what we call it. And you can just plot time series of stack bar plots of concentrations or whatever it is that you want. And you can download data from this site. So that's what I had to share today, and I'm happy to take questions.
This is Swarup China. I'm from Environmental Molecular Science Laboratory, and you heard the name quite a bit from Nikki, Shaima, Chongai, and Avison as well. So I thought to give a little bit introduction about the EMSA just in case. There we go. So EMSA is another DOE user facility from BER. And similar to ARM, it provides support in terms of instrumentation, data. It does not give you a physical dollar, but more like in-kind value. And it has over 150 instruments, several users. But I just want to briefly mention that these instruments are, oh, here, perfect. I didn't see that. So these instruments are nothing without you, the user. So our primary focus is to build instrument for users, help users, and work with you guys, explore the science together, and learn from you your interesting science question you have, and see how we can help with our instrumentation, with the expertise we have, and explore the science together. So you get all this laboratory space, the several instrumentation for free. And then how this thing works. So once you have a proposal that is approved, peer-reviewed, and we can help in refining your proposal, so there's no conflict of interest because we are not part of the peer review. So if your proposal is rejected, It's not my fault. It's mostly the peer reviewers. But again, we are happy to help in terms of putting together a comprehensive proposal. And now I'm going to talk about these 150 instruments that we have. Of course, we don't have time for those. I'm going to talk about just a very focused instrument that are specifically useful for Bankhead National Forest. So I'll briefly mention about this instrument, which is called Size and Time Resolved Aerosol Corrector. So this is started when Jim Mather reached out to EMSO and said, oh, we want to analyze some samples from Tedrat Baboon, and then we realized that we need to probably build a sampler to do the analysis first. So these are all custom built here at EMSO. The size and time resolved. The size of the particles are changeable. So based on your science quotient, we can accommodate the size of the particles, and everything is custom made. So we have this flexibility, and we have been also developing an ultrafine stack, specifically people who are interested in the new particle formation, so that can help to analyze particles up to 30 nanometer or so. So this is still in process of the development. So once we have this stack samples, what kind of analysis we can do? So this is just to give you a brief snapshot of different kind of offline analysis, because we collect these samples, bring it back to the lab. And again, I just want to briefly mention the stack project started as a partner project with ARM, which was very fruitful because ARM helped us to deploy this instrument, the pilot study, and then kind of became the part of this ARM of FICA score that I'll talk a little bit more towards the end of the talk. So now we have the samples, then ARM sent back these samples to us and what kind of analysis we can do. So these are mostly offline analysis, and you can see there are 3 different substrates are used at the same time. So it can give information with our single particle analysis, microscopy and spectroscopy technique, which provide you the size resolved chemical composition. We also have several custom built and in situ stage where you can understand the water uptake potential of individual particles, the hygroscopicity, the phase of the particles, as well as their ice formation potential, which I'm going to talk a little bit more towards the end of my talk. And then we also have a high resolution electron microscopy in transmission electron microscopy. So if you are looking at particles below 100 nanometer, we can look at those with the TEM. The challenges is sometimes it's very beam damaging, but we have a solution for that. So we have a new detector called direct electron detector, which is give you very minimal damage to particles. So you can image them still, with a less minimal damage of the particles. And then there are several surface-sensitive techniques as well. TOPSIMS is a secondary mass spectrometry technique where you can look at the surface chemistry of those particles as well. So again, main point here is that based on your science quotient, you can request for a variety of offline analysis that you can do. So I'll give you one example with microscopy analysis. So this is example from the cell site. This is a project with the Colorado State and the Los Alamos Laboratory. So looking at, and also the Brookhaven National Laboratory as well. There are 3 FICAS projects actually. So we're looking into the defined particle profile of aerosol composition. And in this particular case, we're looking at 2 different altitude and looking into the size resolved composition. So just to give you an idea of what kind of data we can get from this kind of analysis. And again, these are looking into the thousands of individual particles because it's runs in the autopilot mode. So then we have another sampler who is called the bulk aerosol corrector. So for that, this is specifically designed for when you need more mass loading basically. For this high resolution mass spec analysis, you need more mass, but these are bulk samples. So you're looking at the entire size spectrum. So then again, when we develop this instrument, again, I want to give a very kind of acknowledgement to the ARM. They really put into nice package, and if you mention Davy, who is leading the TBS team, who is a fantastic person to work with. So again, they did all this packaging of the instrument and then fire with the TBS. So again, what kind of analysis can be done from these TBAC samples? One of the more commonly used analysis, we use a high resolution mass spec called nanodesi ionization. So the idea of this technique is that you can analyze samples with a very small amount, and you don't need you can analyze directly from the filter, so you don't need any extraction or anything, so that will avoid minimal change in your samples. And then we have a several mass spectrometer. So this ionization, it can be incorporated with the Orbitrap. You heard some of the previous talk. Also, it can be incorporated with one of the most powerful magnet we have, 21 Tesla, that can give you a very ultra high resolution molecular features of your complex samples. So I'll give you one example here. So this was studied at the Southern Great Plain, and in the x-axis you are looking at the carbon oxidation state, and the y-axis you're looking at the volatility distribution. And if you look at the red color here, so that is the organosulfate and the right side. And that is, if you're looking at the two defined wind patterns, so the right side one is showing this more red color, which is organosulfate coming from the southern winds. So basically where you expect a lot of anthropogenic emissions coming in. So you can really see based on the wind pattern, you can predict what kind of molecular composition you can have. And I specifically mentioned this organosulfate because that's something you probably expect quite a bit in the Southeast US region. So again, this is kind of give an example, what kind of analysis can be done for the Southeast US samples. And then I briefly want to mention that this is also compatible with our stack sampler. So we now, another again example of collaboration with ARM, we basically take the heart of the stack and put into the Arctic shark sampler. So there were some samples collected at last June or July this year. Samples are located at EMSOS. We cannot wait to explore those, but we are waiting for an approved proposal. Then only we can use those samples, but it's already collected. And the idea is that we can use these stack samples as well for some high resolution mass spec analysis that we performed. So that's very encouraging. The next one, so we have been keep developing based on the user needs. So then there was some, we had a workshop at some point, and there was quite a bit of discussion on the body organic compounds. So we then developing a system, we call it Travis. Basically it collect the VOC cartridges at different altitude. And also this kind of system has been there in the community for several years. People fly in the drone, but what would be the unique part for this this system is that you can see this white part here, that is the piezoelectric pump. So that used as a mass flow control, a pump, basically inbuilt mass flow control as well as the inbuilt pressure sensor. So it's very kind of very tiny and give you a very high precise volume of sample collection that you need for the quantification of VOCs. And then we have a instrument that we purchased like a few years ago. It's a thermal desorption with a gas chromatography separation and connected with a time of flight mass spectrometer. So we can give you very sensitive measurements. So even though you have a very small amount of samples, you're able to quantify the VOCs. So we are excited to fly this in the upcoming BNF. There are a few approved projects that Travis has been requested, and we're excited to share the data with you guys. Next, I will talk about some online measurement. So this is pretty well known in the aerosol community. This is ALA's mini splat, so single particle mass spectrometer. And I always say that there is nothing you cannot measure with the splat. So you name it, size, composition, density, mass, volatility, everything you can measure from this instrument. So very powerful. This is just an example. You get the example from the biomass burning and one from the soil dust. And the right side also, you can look at the residuals for ice nucleating particles. So once you have a ice nucleation chamber, for example, you can separate the ice crystal with the palm counter for virtual impactor, and then connect with the mini splat or other offline analysis. You can get the composition of ice crystal residuals as well. So very powerful instruments. Then I'll talk a little bit about the bioaerosol, because as Avison already mentioned, Avison Steiner in her talk, the importance of bioaerosol for the Bankhead National Forest. And we have been trying this for the last several years to better characterize these bioaerosol in the atmosphere. So here we have two methods. One is online and offline. So online is the WIPS instrument, which basically provides the online in situ measurement of fluorescent particles, not necessarily biological particles. So anything fluorescent that will detect. So if you're looking at the biomass burning plume, you have a lot of pHs, it can say, oh, there's the fluorescence particles, but not biological particles. So what we have been trying, and this work again started with a collaboration with Alison Steiner, her PhD student Ying Zhao, former PhD student. So she started this project, and I'll briefly mention that there was some excitement that when we started, basically we are building a database for defined biological particle mixture using a machine learning model, train it, and then our idea would be to provide, instead of a fluorescence particles, real-time measurements of types of biological particles. So real-time measurement of how much fungal spores you have, pollen you have, or bacteria you have. But I'm excited, but also a little bit scared, because what I heard this morning, there was a lot of pine here. So pine is something that this instrument doesn't like, the optics. So it's very sticky. So that's how we have been offline for almost 1 year. So it should have been completed almost a year ago. So we got the instrument back. We are finishing up and hopefully this product will be available before March, before we deploy this instrument for Chongai FICAS project at the BNF. So again, this will provide a real-time measurement of specific biological type. And then we have an offline analysis as well. For identifying biological particles using traditional microscopy spectroscopy technique is that it's very difficult to distinguish between some of the carbonaceous particles. So if you use a standard chemistry-based, rule-based method, it always underestimates the fraction of biological particles. So what we did is we built again a database. We manually looked into some of the specific biological particles from ambient as well, put that into the training model. We have a standard particles, developed a machine learning model and a software called BioPack. Basically, again, this is available for users now, and we have been using this application for some of the current FICAS project, for example, Alison Steiner Tracer project, some of the SAIL project for Maria, and Alison and Paul Demott, actually. So again, you can see there was an example of a flight profile from Southern Gateway, and if you see there was a machine learning is giving a little bit better prediction or quantification of the biological particles, and our hypothesis, which was kind of makes sense here, that the traditional rule-based method under-predict the fraction of biological particles. So again, this is constantly evolving. We are still improving. The more data you have, better train your model, better prediction you can get. So now we're talking about the Eisner equation, and my last few minutes will be talking about the Eisner equation, because as we talk about the biological particles, the ice formation is very important, specifically for the warm temperature range. So what kind of Eisner equation platform we have? And this I feel very proud, because we have a lot of Eisner equation related measurements, and something that if you're interested in Eisner equation research, you have to come to us, work with us, and we'd like to work with you again. So we have two online instruments called CFDC, and recently acquired a Pine chamber. So that will give online measurements of Eisner equating particles. The CFDC has been around for several years. The Pine is recently acquired, which is kind of give you more continuous measurement with minimal maintenance. And then we have this Eisner equation platform integrated with our environmental SEM and SEM. So this is more like a fundamental studies, more mechanism related, where we can look at the single particles. We can understand from why ice is forming. We can also looking at the residuals, which particles are nucleating or which particles are not nucleating. So these are the offline measurements. So now, I think this is my last slide, or second last slide I have. I'm very excited to share about the other two emerging capabilities that we have under EMSO. So these are existing project, is still not available for users. It will be available in the next exploratory call. So this is a experiment led by GK, where he's developing this his CFDC integrated with a spot sampler, basically. So that will help us. It's a very clever idea, actually. I'm very excited about this. So it can give you online measurements of ice nucleating particles, even up to -3, -5 degrees Celsius. So this is very, very unique and specifically important for Bankhead National Forest, where you expect a lot of these biological particles. And often we rely on offline analysis technique for warm temperature freezing. So this will give you a real-time measurement of warm temperature biological particles, as well as, if you look into the residuals, you can look at the warm temperature residuals as well. And the second platform is about the offline analysis. Again, this is a freezing assay that you can see many many labs, academic labs. But I would say the unique part here is that we're trying to improve the uncertainty. So what we did is there was a specific platform is used for proteomics analysis called nanopods, what it does is basically have a robotic automatic dispense of a very precise volume of droplets. So that has been integrated to the freezing assay system, which will give you more accurate measurement of your heterogeneous isotope equation rate. So significantly improve your uncertainty. Last week, this is my last Friday, and talk about like we like to work with you, collaborate with you. So how we do, there are defined proposal mechanism. Please reach out to me if you have any question, but briefly, I think the two most important one is the large scale proposal and the ARM ficus. So the ARM ficus one, you heard this the term before. So basically, when you have a single proposal, two user facilities working together. So you submit a proposal, you ask ARM to flight specific time, specific location, design your flight profile. The samples come back to EMSO and we do the offline analysis. And then in case you have samples or you have a collaboration where say you collect a sample from a different mechanism or even for us. So we also have ARM proposal. For example, we had an ARM proposal to collect sample at the cell site and at the AOS. And then we collaborated with Paul Demott and he needed those analysis of sample for his study. So this was again perfect example for large scale research, again working with ARM. And both are 2 years projects. We have plenty of time to do the science. And there are some exploratory research calls as well, specifically designed for those emerging calls. With that, I'd like to thank you and again, hope to work with you. Thanks.
Thank you, Swart. Questions?
Sarup, thanks. In the spirit of the scientists being untethered to reality, asking you about new capability, what options are available to make in situ fluorescence active measurements of aerosol on a tethered balloon? Are you aware of any like commercial technologies or? So as an example, like can we put a WIBS on a TVS?
I'm just not sure. I'm supposed to talk. There was a project called from DoD. They have been talking about defined technology. So I'm not 100% sure I'm supposed to talk about this. So I'm probably keep my silence here because that was the whole idea to kind of looking for sponsors and kind of see what is available or not. And they said it's kind of I just want to make sure I'm allowed to talk about that.
I will say, I don't know about that, but I will say that the SBIR topic that we had for atmospheric measurement technology this year did include a subtopic on bioaerosols. So we might see some more technologies coming out in the next couple of years. But to be clear, you're only approved for the WIBS to come on the ground right now. Anything else? Sebastian, can you wait another talk? Dawn's online, and I apologize, we couldn't get everybody here in person because a few people had some conflicts. And so Dawn Lemke from Alabama A&M is going to present online and share her screen. Thank you, Sebastian, and everyone for being flexible. But we've pulled her out of another meeting, so I'd like to let her get back to her other meeting if that's okay.
Well, thank you for that. Yes, I managed to have a conflict this week and on a USDA panel, so it was great that I could at least do this remotely. Just wanted to, I know, would have been really nice to be there in person and meet with everyone. So my presentation is a little bit different in terms of collaboration and sort of working towards sort of a very integrated project by the looks of it with lots of different components. So Dr. Desi is there in the audience and he may follow up a little bit more on this. But we want to talk a little bit about Alabama A&M. We're a university based in Huntsville. We're a land-grant minority serving institution. And I work within the Department of Natural Resources and Environmental Sciences. Dr. Desi is the chair of that department. And within our department, we have both environmental science programs, forestry programs, plant biotech programs, a master's and a PhD program. And a lot of what we do really focuses on workforce development and engaging students in science and understanding scientific process. So I'm going to talk to you a little bit about one of the projects that I have, which is not in the Bankhead National Forest. It is a little bit north east of Huntsville in the Paint Rock Valley. And it is the Paint Rock Forest Dynamics plot. It's part of the Smithsonian Forest Geo Network. And it is a space that we have worked to create an environment where we can train students in forestry and ecology through very immersive experiences, creating data sets that I would very much welcome a collaboration on, but we could build out for our students and research projects in the area. So the forest is sort of a mixed hardwood forest. It's about 30 minutes from campus, which makes it pretty accessible for our students. And we have a 20-hectare plot where we have measured every tree within that and located it. So here's a map of the site. As you can see, the Bankhead National Forest is down about here. It's part of the Nature Conservancy's Sharp Bingham Mountain Preserve. So a lot of relatively unmanaged forest in the area. So it started in 2019, and we have the area surveyed in 20 by 20 meter quadrats where we have measured and mapped every live stem that is 1 centimeter at DBH, and then identified the trees to species, or at least the majority of them. We're just completing a recensus on this, and we've added to that canopy position, lean angle and direction, with the idea of integrating some different remote sensing information. So in the first census, we had just over 27,000 trees, 35 different families represented. Of that, there were 4 species with only 1 individual. So we're about 70% through the remeasure and have found about a 1% increase in above ground biomass as we've gone through it, with about 3% recruitment rate and 13% mortality rate. Outside of that tree data set, we've other information overlaid, including leaf samples, tree cores, soils, dendrometer measurements, weather stations, LIDAR, and hyperspectral. And a lot of this work is done in terms of student training, engaging students in the data collection, as well as the data analysis side. So we have a very limited number of leaf samples taken at the moment as a preliminary study that we're working at building out as a project with the University of New Hampshire and Smith College, and looking at how different species potentially have different responses to drought across different areas of the country. Also looked at some soil work across here. A lot of this is currently being analyzed. We have some of the trees monitored every hour with the dendrometers. So we've got information across a couple of growing seasons, and it looks at measurements every hour of temperature and diameter, as well as a couple of weather stations. I don't know if Casey is on the call at the moment, but I know she's been part of some of the work down on the Bankhead as well. She is at Oak Ridge, and she's worked with us to fly some LIDAR data, which we flew last summer as a leaf on, and we will look at flying again in January for leaf off. We've also worked on looking at some hyperspectral data, and we've got a couple of different growing seasons for this. We did some handheld analysis of leaf spectra and looking at the variation between species and across species. But fundamentally, this project is about giving a space for experiential training by sort of fairly intensive field engagement in sort of ecology and forest science. Across this about 5 years, we've had a field crew of about 30 on and off, involved about 20 undergraduate students and 4 graduate students. And to me, that's what I really enjoy is the teaching and the sharing and the engagements of students in science, and would love to work with any of you on building that out as much as we can, while still meeting all your science objectives. But how can we create that next generation of scientists to build on this? This is one of my graduate students. He's integrating some of the hyperspectral data, looking at assessing the canopy mapping, tree mapping using the combined remote sensing techniques of LiDAR and hyperspectral. Another one of my graduate students here is looking at the drought resilience of different tree species. This is some preliminary data down here we collected last summer. Some of the data was taken at Harvard Forest, others at the Paint Rock. And you have different trees have different responses to drought, but you've got both the variation within the plot and the variation across the different plots. And so found the white oak and red oak from the preliminary data were a lot more drought resistant on our site than the one in Harvard Forest, whereas beech had the opposite response. So generally, what my goal is that we create a wonderful space here for learning and research. It's collaborative and open, and starting to look at some of the very local scale interactions, individual species variations, and things along those lines. And like I said, I'm not there today, but I'm normally on campus or in Huntsville. My contacts are here, and feel free to reach out to me. And I think Dr. Desi may speak a little bit after me and talk a little bit more about the program.
Thank you, Dawn, and thank you for joining us. We appreciate it. Is there anything?
Yes, so I have a couple more slides here that Dr. Desi asked me to share, and these show some of the other researchers on campus. I don't know a lot about these projects, but they are funded through DOE as well as through NASA. So we have an applied geospatial data science initiative for urban climate change studies. And then, Dr. Desi, is that you?
Yeah, I'm the PI for this project, so I thought this is a little surprising for me. I'm not very well prepared, so let me give you a brief overview. I'm the associate professor in the same department with Dr. Lemke and Dr. Tadesi. I started in 2022, and this is one of the new grants that we got from the DOE Renew program. I will not go into the scientific aspects very much, but the overarching goal is to train the next generation of scientists, especially to bring the minority students into the DOE research. So we propose to develop geospatial data science initiative. This is for the urban applications. As we know, urbanization is happening and contributing to global warming. So we picked the Huntsville area as it has been going through a lot of developments over the recent 2 decades. So our goal is to bring the atmospheric modeling approaches into the GIS and remote sensing environment. So we will bring remote sensing and GIS data and analytical techniques to see how the urbanization has been happening and how it is contributing to the urban heat island effect. Mainly, we have 2 domains, and first one at the small scale, we are looking at the Huntsville area, and our goal is to expand it to a larger scale, depending on what we see at the small scale studies. Next one. This is another project that this is actually a sub-award. We are working with Bethune-Cookman University, another minority serving institution from the Florida. This is on the coastal ecosystems. This is my first priority, actually. I have been working on the coastal wetland ecosystems to see how the coastal wetland vegetation, the productivity, and the disturbances have been changing over time, especially at different spatial and temporal scales. This is also, we are trying to bring in new technologies, AI and machine learning algorithms to incorporate with remote sensing and GIS techniques. One major component over here also to bring in the undergraduate and graduate students from minority institutions. I think that is, do we have any other slides? Yeah, I think that is all from me. But if you have any questions, for me, my goal over here is to look at the BNF, how the different data and different the opportunities that we have to bring in new students, and also for us to expand the research into other areas as well. Currently, we are working on the urban landscapes and coastal wetland ecosystems, but we would love to apply the same techniques and same the approaches into the forestry environments as well. So I'll be more open for the collaboration for any questions. Thank you.
Okay, any questions? Okay, thank you all very much. Dawn, thank you again. Sebastian, if you want to tell us about Mariflux, and I don't know if you include any of the tower items or not? Yeah. Okay. Couldn't keep him.
Oh, yeah, here, indeed. So good afternoon. Today I will talk to you about a few reasons why Ameriflux is eager to join ARM, the ARM program in its new AMF3 deployment in the Bankhead National Forest. My name is Sebastian Birod. I don't know who is on that picture. I mean, something happened, but I'm a biogeochemist at Lawrence Berkeley Lab, and I serve as the Ameriflux Management Project deputy lead that Margaret Thorne is leading. So you could ask, why now? ARM has been around for quite some time, and Ameriflux has been around for quite some time. But I believe that the AMF3 deployments present a really novel opportunity to leverage the multi-scale observation across the main and supplemental facilities. Right? As we've seen, there's a lot of heterogeneity across the landscape in the BNF campaign area that are being built at the moment. To explore the connection between plant ecophysiological processes and atmospheric states. And because the deployment is slated for 5 years, we're going to have seasonal and interannual timescales. How is this going to happen? So those measurements of surface energy, water, and radiation fluxes, relative fluxes, are going to be made using a decovariance technique. Micrometeorological and radiation measurements will be collected within and above the canopy, which is something very new for ARM, right? Really going into the forest. I was trying to remember, maybe Sally can comment, when you did go Amazon, if there was any sites in the forest. I don't think so. So I think this is really the first time that this is happening, together with large-scale vertical atmospheric boundary layer profiles. So these measurements will offer a unique test bed to investigate the direct and indirect connections between environmental drivers and plant ecophysiology and ecosystem fluxes. And I've heard a lot of interest from the forest services, from PIs at the University of Alabama, Huntsville, on that link between forested area and the atmosphere. And I think this is really a good case of synergetic activities between two DOE programs, ARM and ESS. ESS, Environmental System Science Program that funds Ameriflux Management Program. So I think it's a really, really good case. But first, what I'd like to give you is some information about what is that thing that I call Ameriflux. So the Ameriflux network, as I said, has been created quite some time ago in the early 1990s. It's first a network of flux towers across the Americas. measuring turbulent net carbon, water, and energy fluxes between terrestrial ecosystems and the atmosphere using the eddy covariance technique. So we saw a picture of one of the team from University of Alabama that was showing an eddy covariance system, but that's the technique that you have to use in the Ameriflux network to be part of the network. The Ameriflux sites represent a span of climate and ecological spaces, natural disturbances, and land management to quantify spatial and temporal variation in carbon storage in plant, soil, exchange of carbon, water. So usually we're mostly focusing on carbon, but water is a component of Ameriflux, and energy between in ecosystem across a range of latitude, disturbances, histories, and climatic conditions in the Americas. Here I'm showing you not an exhaustive set of pictures, but a bunch of pictures of flux towers in area ranging from the North Slope of Alaska, which is our northernmost sites, to the Florida Everglades and the tip of South America and everything in between from short and tall canopy, right? From crop ecosystem, which could be a couple of feet tall in Oklahoma when we do a winter wheat, to corn that could be 12 feet tall, to tall forest, the redwood forest in California that are 120, 130 feet tall trees. In the lower center part, I'm showing you pictures of how the network has grown steadily since its inception. Especially, you see an inflection point around 2012 when DOE gave the management of the network to a national lab, Lawrence Berkeley Lab specifically, where there's about now 40 to 50 sites that are added each year in the last 10 years. As of today, and it was going to be announced today, but I think I checked 2 minutes ago, it's not there yet, it's still at 499. As of today, the network has more than 675 sites registered, with 500 sites with data, right? And the 500 sites with data, there's a press release that's coming today. I thought it was going to be on, but it's not. 87% of the data available from those 500 sites is under an open data sharing policy, CC by 4. So the data that we provide, that the Ameriflux network provide, brings information and new knowledge that are really, really central to the DOE BER mission to understand complex biological and environmental systems across spatial and temporal scale by joining theory, observation, experiments, and models. The Ameriflux network is also not only a network of towers, but it's also a network of scientists, right? Scientists that collect the data, and a community of scientists that use the data, right? So we have about 200-300 site teams that provide data to the Ameriflux network, but the community of users is very, very large. We have about 18,000 people registered to use data on the Ameriflux network. Every year, because we want to foster that community, the sense of community, we hold community meetings. It was not every year during COVID. There was a little bit of a hiccup, but the last one was held last September in Berkeley. That's the picture you see on the upper left, where there was more than 100% attendees and about 150 attendees remotely. We also hold a community town hall at AGU every year. The next one is next Tuesday, December 10 at 12:30 local time. Please join us. We also hold regional hands-on workshop to help data team and data users to better understand how to best use the data that we're collecting. No, come on. Okay. So this figure that I've put on the lower left illustrate existing tools and approaches that we can use to quantify carbon pools. Remember, Ameriflux is really focusing on carbon. We also have water and energy, but it's principally focusing on carbon and greenhouse gas emission from terrestrial ecosystems. There's a general trade-off that exists between accessibility of these tools to the broader community, right? It's harder for people to use sometimes remote sensing technique when you're an ecologist and you're interested in what happens at the plant level or leaf level. But the Flux Tower really sits at a scale between a leaf and remote sensing products, typically a few square kilometers, which is good scale for models. Flux towers have also a high degree of robustness, meaning that they are measuring continuously. the net flux of CO2 between the atmosphere and the ecosystem, as well as a full suite of related water and energy cycle variables, right? I keep bringing those because I don't want you to think we do only carbon, right? We do carbon, water, and energy, so there's a lot of those. Furthermore, measurements collected by flux towers connect processes that are happening between the land surface. So we look at the soil, the within canopy, that's going to be very critical for the Bankhead National Forest development, the top of the canopy, and the lower atmosphere within the boundary layer, which give an idea of the vertical scale integration that's going to be very relevant to this deployment for ARM. You can imagine about key variables, right, that we collect using that technique that can apply for land-atmosphere interaction studies or for colleagues that are more ecologists or interested in forest status and health, right? I mean, same sort of fluxes. So surface fluxes, we're going to measure latent heat and sensible heat that are really important for the model and understanding the dynamics in the region. We're measuring, surface states of soil moisture, surface temperature, net radiation, and more variables. For forest status and health, we're going to partition those, for instance, net carbon fluxes into photosynthesis and respiration. For water use, we are going to partition between evaporation and transpiration, and we'll have sensible heat fluxes that give us an index of heat stress for the plants. Okay. So why are we interested? Also, another reason, having a site located in the Bankhead National Forest is because this site represents a gap in our current network. I'm showing a figure of a land cover map in the southeast US. I was telling Bev that I wish I had a map that she had because it's a really nice map. Mine extend a little bit west of the Mississippi Valley. And this map shows you active Ameriflux sites for forests, crop, grassland, wetland, and savanna ecosystems. The BNF sites, the M1 I think it's called, is located in the center of a roughly 300 by 400 kilometer area. It's about 46,000 square miles. It's a little bit smaller than the size of the state of Alabama itself, but it's a huge swath of land that's void of flux measurement. So very, very interested for this. For Ameriflux, contributing to the Ameriflux to the Bankhead National Forest deployment, and also a new site with a rich set of atmospheric observation to support the analysis and understanding of land atmosphere exchange. This combination has proven in the past that it's a very, very useful set of rich data sets for the sites that the ARM site, US ARM sites that ARM is supporting since 2001 in the Southern Great Plain of Oklahoma. Data collected at these sites, it's a crop site, it's mostly winter wheat crops. It's one of the most used Ameriflux sites in the network for crop ecosystem with more than 2,000 downloads since we started collection. So we're very hopeful also for this site that's going to provide new insight on forest dynamics and coupling with the atmosphere. So I don't know if our colleagues from NEON are here, but for reference, I'm showing a picture of the two closest Ameriflux sites to the Bankhead National Forest that are operated by NEON. One in the Talladega National Forest, and the other one in the Great Smoky Mountain National Park. And those are, here, I guess. So that's the Talladega, and the other one here is the Great Smoky Mountain. So just, where is Nikki? So although Ameriflux site team has a lot of experience adding flux towers in forested ecosystem, I guess we don't all have the same experience of building those. And something that is very humbling is working with university and national lab is not exactly the same burden. And my hats to the team also to pull it off, because although I don't want to jinx it, but so far, amazing anyway. And so I'm showing an example of towers that Ameriflux has been deploying in different forest ecosystems for a long time, right? Most of them, although have been deployed in the mid-1990s to early 2000, Well, I guess oversight was not exactly the same as what we have right now. So we worked a little bit with the science team also, fantastic team. It's been really a great learning experience, even for people that thought they knew a lot about flux towers. So thank you for your patience with us also. There's a lot of things that we're learning and a lot of things we want to do with you guys. So that's fantastic. What we are bringing also is the Ameriflux team has a lot of experience with sensors that I've commonly used across the Ameriflux network. And most of the installation that we're going to see for land surface flux measurement, carbon, water, and energy, using equipment that many Ameriflux sites have used, and with established QA/QC protocols, processing code to generate data product for the larger scientific community. So not only we're going to provide data stream that are common to ARM, but we're working with the science team to develop the next level of PI product. I'm going to call them PI product, but really bringing value-added product to those data streams. And then because of this, data collected at this site will be interoperable with all other Ameriflux sites, so which is good, and that's great for synthesis study. I think that's, yeah, I guess that's the type of instrumentation that Ameriflux contributed to ARM, but I think that's, we'll end on this.
All right, thanks. I'm gonna put my community hat on and take off my site science team hat for a minute. But I am trying to represent a larger community of researchers at NASA and other locations that are interested in thinking about, I gotta look down here, opportunities to bring new capabilities and platforms to leverage the AMF3 site and consider new ways to do land atmosphere research in collaboration with institutions locally. And a lot of the conversation today has been giving me a whole lot of ideas of how to engage better and folks to reach out to in the future. There we go. So Chungai brought up this slide earlier, so I won't spend a lot of time on this, and I also want to give Alex time to talk about a recent campaign that could be a good template for the Southeast. But this talk is really thinking about the land atmosphere interactions research opportunities that we have with BNF, and the way that we could look at the land atmosphere two-way interactions and coupling from the surface to the atmosphere and the role of fluxes, energy and moisture, as well as the role of plants in aerosols and biogenics, and how they impact convection in the short and long term, and play a role, how the land surface heterogeneity plays a role in all of that. I'd like to quickly provide my domain-specific metaphor and say that it's really exciting to see the site take root and all these locations emerging across the domain. It's been a while, and it's really exciting to see just it really take shape. These are photos from yesterday when we did the tour, and I hadn't seen any of these actual sites being built out yet. And it's really great to see. So again, the Argonne team's done an excellent job keeping us contained and constrained and leading the charge to get the site built out. So now we have some real concrete opportunities here to start to make use of the site and think about ways that we can develop IOPs, airborne campaigns, and collaborations to start to connect the surface of the atmosphere in new and novel ways. One of the challenges with working anywhere, but in particular with the Southeast, is that you have these different scales of heterogeneity. Within certain areas, you have a lot of arguably representativeness or homogeneity in the system, but as you zoom out and move across different boundaries, you start to have changing surface conditions, changing heating, moisture interactions with the atmosphere, different vegetation, different seasonalities, different albedos. All of that plays a role in how we understand the regional climate interactions and things we need to consider when we're looking at modeling and scaling up to the larger domain. So how do we do that? Being a NASA scientist, I would argue using remote sensing. So how do we move our understanding from point to pixel to planet? Those spatial temporal characteristics of the surface really play a strong role in land atmosphere interactions in that coupling, as well as the boundary layer. However, in our modeling, we often
don't have enough representation or good parameterization of the heterogeneity, and that missing parameterization and process representation at the right spatiotemporal scales drives a lot of the uncertainty we know in our weather predictions, particularly in complex domains like the Southeast US. We really need co-located space and time surface atmospheric measurements with airborne campaigns from the ARM aerial facility, from NASA, from satellite platforms, from university assets, to be able to better understand how all of these different scales couple, the time lags involved in those couplings, and how do we incorporate that into our ability to forecast weather. We need new approaches in modeling to flexibly combine. We're talking a lot about even just the AMF3 deployment itself. There's a lot of heterogeneous data. How do we use that information much more quickly to start to understand how to improve the model parameterizations? And then how do we then do that when we're thinking about remote sensing data? And arguably, I think everyone in this room would agree that the AMF3 provides an opportunity to start to think about that really deeply and provide new opportunities and capabilities to embed into our process understanding. So what I really wanted to bring up here before I hand it over to Alex is one potential opportunity and hopefully a series of opportunities to work with all of you in the Southeast. So this coming fiscal year is the next year of the SARP, Student Airborne Research Program at NASA. There's now an East Coast and a West Coast version of this. In the past, various different airborne platforms and instruments have been flown, one of them being Kickoff, which is an airborne flux system from Glenn Wolfe at NASA. We've got some funding this year coming up to fly again, both SARP domains, as well as fly in support of the Greenhouse Gas Center and prototyping the Farm Flux initiative from Glenn Wolfe. One of the things I've been pitching for several months is to fly those assets down over the Southeast and over Bankhead. In addition, the idea is to fly the same domain as SARP East 2024, which included Baltimore, so there's strong connections to Courage, as well as some of the coastal and forested areas in the regional domain around Goddard. In addition, for my group, the G-Light platform has been requested this summer both to fly over Baltimore as part of Courage, but also fly some locations in the Shenandoah related to coal mining. And if we have the opportunity to fly it down here as well, I would really like to make that happen, at least this year, but potentially a couple of times in the future years to look at forest change. That system and that platform comes with a dual LiDAR system, thermal imager and imaging spectrometers, as well as RGB cameras. So there's a lot that could be done with that platform, and I think could be really good to link with the modeling capabilities, including what I've heard in terms of the research interests and LES modeling interests that have been coming up today. And then I'll just quickly hand it over to Alex, but just to seed some of the discussion that we're supposed to have perhaps before we end the day today. Thinking about observational needs, what has come up today, Sebastian brought up some great opportunities with the Ameriflex system. Dawn brought up really cool opportunities with students and the things that are going on in the region. Lots of discussions about tower networks and capturing regional heterogeneity, the Solaro effort and the new ESS call. I think there's opportunities to start to link a lot of different science together. How can we do that? How can we use airborne campaigns? How do we incorporate ARM's aerial facility and the Arctic Shark? What role do they play? A few ideas, but pitching perhaps one would be that the use of UASs give us that diurnal signal that we're often missing, whereas the airborne piloted systems give us the much more larger regional domain. Combining those two with the ground campaign would be quite powerful in this region. And speaking of combining ground and air, I just want to hand it over to Alex to talk about a recent campaign that could also form a template for a future opportunity here.
Great, thank you, Sean. So let me advance here. So just to give an overview of where some of this motivation for this field campaign I'll be talking about comes from, some of you may be familiar with this National Academies of Science report that discusses, what do we need to look at in the next decade? And there was two particular incubation study areas that were highlighted. One of those is PBL, another one's STV. So through these different areas here, different projects and technologies have been funded to basically look at this incubation over the next decade to figure out what does a mission look like, either for PBL or STV. We know they're interconnected with each other. So, how does technology advance to address these needs? And what do we need to do from the science perspective? Because we know it's not just remote sensing from a satellite. We have ground components and suborbital that can fill in the gaps. That's critical for understanding, what does the PBL or STV look like over the next decade. So there was this field campaign that we actually just wrapped up last month. Actually started off as just the West Coast hyperspectral microwave sensor intensive experiment, but then we expanded it to the heartland, so looking over the plains, looking at a variety of more surface types. So it started off as just a NASA ESTO funded field campaign, where we got a couple of different instruments that were being developed, particularly a hyperspectral microwave instrument, and a couple of other PBL relevant instrumentation that were being developed and needed to be tested. NOAA came into the picture saying, hey, we're interested in some of this technology development. So that's how this started. And we added more and more to this. More collaborators were added to help complete the picture and make this more of a PBL pathfinder, for lack of a better term, in understanding if we're going to better understand PBL or even STV, what type of instrument combination would be ideal from a satellite remote sensing perspective to put into space eventually, and how it can be done affordably, of course. So really the main objectives is really looking at the PBL, but I'll keep coming back to STV being a really important part of this too. We originally are focused on the PBL, cloudy PBL and convection, extreme weather. But as we continued to plan this field campaign, we needed more information about the surface. So we addressed that through multiple different collaborations with ground-based facilities. The DOE ARM SGP site was one of our core over land sites that we used for understanding this interaction between the surface and the PBL. So this is just, I'm not going to read this whole thing, but this gives you an overview of our primary objectives, one of which was demonstrating this new hyperspectral microwave instrument. The really take-home message here with that is that when you look at what data is assimilated into numerical weather prediction, microwave adds the most value to the forecast. So this is a new instrument that in theory will be able to have sensitivity in the PBL, and this was our first opportunity to show that from an airborne perspective. You can see down in the table to the right, we have our complete payload on the ER2 and the G3. And the key here is, we originally just started off with that instrument at the top, Casimir H, and then we added all different types of passive instrumentation that can help fill in the picture, whether it be infrared instrumentation, active, such as the cloud physics LiDAR, which, in addition, aerosol backscatter provides specific information about clouds. On the G3, we had Halo, which really added a nice piece because it provides water vapor and methane curtains. So this is all to say this, it turned into more of a fully integrated field campaign, not only focused on PBL, but has surface relevant measurements such as we added master on there to provide the visible, the visible and shortwave infrared information about the surface. So, and you can see some of the other collaborations we had. Particularly, we had, of course, I mentioned we were at the ARM SGP site, but we also had UAS there. We had other UAS imaging at this MOIST site, which is south of SGP, that specializes in soil moisture measurements. So that's all to say the surface, and once again, the surface and the PBL are really interconnected with each other, and that's kind of how we designed this over time. So our overland, we flew half of our flights over land, half of our flights over water, for a variety of reasons. Over water, the surface assumptions you need to make for some of the microwave retrievals are not as stringent. So really understanding the surface is not just important for doing PBL science. It's important for really any satellite remote sensing you want to do. You need to have a good characterization of the surface. You can see we were based out of California. We flew to SGP 3 times, and the real motivation for that, in addition to having the validation from radiosondes at that site, was the surface is well characterized, and we would like to develop some improved surface emissivity models, which is key for not just the microwave, but for other satellite remote sensing sensors as well. And we also flew one flight to Nebraska, which was key because we wanted to overfly the Ameriflex site at the Meade, Nebraska site, where we also had additional ground-based trailers and a University of Iowa aircraft doing imaging of the surface for, once again, doing surface to atmosphere studies as well. And then I will end with this. This is some first light whimsy data. This was from our flight to Nebraska that I was just speaking about. You can see there's some veneer composite imagery from the University of Iowa aircraft using University of Nebraska imaging instrumentation. You can see in the lower left the University of Wisconsin HSRL providing some vertical information, giving us some insight into the PBL throughout the day, as well as a Weissler wing cube providing 3D winds. So once again, this integrated approach was really unique. For NASA, I would say this was, we filled up all of the aircraft as much as we could to provide the most out of this opportunity to get integrated science and hopefully give us some insight on how we'd want to do other campaigns in the future and what instrumentation would be most valuable to have for doing PBL science and designing hopefully a future PBL mission. So that I will end.
Thank you, Alex. Thank you, Sean. Questions? These two are very confident in assuming there are none. They're headed back to their seats. Oh, Sean's hiding. Sorry. Okay, that makes sense. No questions, ideas? Okay, well, you'll know where to find them if there are more. Okay, I think I'm up now for your last. So we've talked a lot about opportunities, and so I think we're going to switch over for one option of what you could do when you link up with an opportunity, and that's looking at ARM field campaign processes. We call them AFC, ARM field campaign. Sorry for the shorthand, but I just want to give you a rundown of kind of where to go, where to get started. Those of you who are actually in the room who all has submitted an ARM field campaign before. Looking at all of you. Okay, so look at these people with their hands raised. Feel free to ask them questions. They can help you as well. First thing to do is create an account. And like I noted before, you can look at the bottom of the ARM webpage and you can find ways to get this. So if you get lost, go there. If you get lost in addition to that, ask us. So get started creating an account so you know what's going on. You're getting our newsletters. And the Atmospheric Observer comes out monthly, and the ASR News also comes out monthly that you've heard about. We also sometimes get ASR working group information. That's a part of our joint meeting as well. What else do we have here? Other reference material is also on our website. And again, the acronyms, and I apologize, this is part of my earlier one, but I like this one, so I didn't want to change it. And there we go. Okay, for the fun and eye chart that you're going to get here. So for Bankhead National Forest, obviously it's a little bit more complex than our other work. So we have specialized flowcharts for how long you need to start preparing in advance to work with us within Bankhead National Forest. So this is a working relationship with the U.S. Forest Service. The timelines that we have within here include both of our timelines. So this is what we believe is max. We're trying to give you an ideal situation so that you don't get caught with something that isn't approved when you're ready to do your research. That could be a major, major problem. So these are I hope these are updated in the field campaign guidelines. I think I updated them for this moment. I will get these out there. The flow charts, the logic is absolutely in there. And it really basically is, if you're doing a small field campaign within the ARM boundaries of the main site or the S10 tower site, something that's in our control, you're not going into the subsurface, you're not doing anything invasive to the trees or wanting trees cut down, things like that. It's going to be the standard ARM timeline. You could submit those year round. We review them monthly. We are pushing back a little bit. If you don't provide your instrument support request, we're not going to review it yet. So please, if you have instruments, we need to know what hazards they are. We need to know what power they need, what space they're going to take up. It's not really hard, but we do need to know that before we review them. If you have something that's slightly complicated, so something that's non-invasive but falls outside of the arm site, we want you to propose that. We're going to work with Andy, and we may have some changes, but we'll try to make it as fluid as possible. We need you to think about 7 months and submitting 7 months prior to your work. This would be tree tapping or coring, harvesting or removing any sample from the forest, anything that has a non-ice safe laser component, that level of things, please try to get it to us at 7 months before. If you can't, we understand. We think it will take less time, but we can't guarantee anything. So please just think about that and get it to as early as possible. On the Ask Us, if you'll talk to the ARM site operations groups, site operations manager, Mark, Mike, Patty, we'll work with you. If there's something that's a no-go, we'll do our best to not waste your time. If there's something we know we can't support based on a chemical, based on something we know or we've been told no, we're not going to waste your time. But get the conversation started early and get that in there. If you have something that is very invasive, so this would be anything from cutting trees down, aerial activities. There's some things that are very set, like Andy noted. We know how the public can operate certain things. There's some things that are not. Typical aerial activities need a lot longer. So we need you to be talking to us at least, if not submitting 24 months out. Anything tree removal, excavation, digging down in the soil, things like that. Please talk to us very, very early. So we'll walk you through this. We will refine it. If we can narrow these times down over the years, we will. But this is our starting point, and we're going to work with you the best we can. I pushed it, and the big green button, right? I feel like I had to be in the right spot earlier, but oh, there we go. Okay, so to get started, go to our ARM campaign webpage. If you look at the top, the research tab that's highlighted, if you click that, underneath that, you will find this campaign webpage and start from the top. You'll see ARM's mission, and if you don't align with ARM's mission, this probably isn't where you should be proposing to, obviously. We give you other information and links to the EESSD strategic plan, ARM facilities, and the focus on our strategic goals. We put reminders in here, again, like I noted, the instrument support request is important to us, and proposal deadline calendars. So we're trying to help you know that you need to do stuff or as early as you need to. We're trying to be transparent there. Just keep hanging in there with us. We also note our field campaign guidelines. We link to the document. It would be great if you read that, but if you read nothing else, read from top to bottom down on this page. That would be the place to start. You'll be amazed at what questions we get. We note in the middle here, our campaign processes. So we support everything from small guest instruments to site visits where someone has brought an instrument with them, takes a sample, goes away. These don't cost a lot of money. They don't require a lot of support from ARM. We can handle those monthly. And this will give you information about those small campaigns. We talked earlier about our annual facility calls. This could be anything from our aircraft, our manned aircraft, our Arctic Shark, the TBS, and then sometimes our AMFs. This year we will not have an AMF call because we're booked up far out, but we will have one the following year we're planning. Again, we note the guidelines, and on to what's required of you. Please read the instructions, submit your campaign, wait and work with us. Depending on the complexity of your proposal, we may have more questions, or it may need something that it's going to require a lot of support, and we need an abbreviated proposal from you that we can send out for scientific peer review. So just work with us on that, respond, and then for approved campaigns, we conduct them, and then we close them out at the end. There's a couple of requirements. If you have a guest instrument, within 6 months, we need to have data in the ARM archive in the PI area available to users, and you need to complete your final campaign report. If it's something that you have an instrument on site that you want to extend, there is an opportunity to extend. You can request an extension. You'll be required to do an interim report we can review, and then we can extend. You still will be required to put your data in. Talk to us. A lot of data is different. A lot of samples are different. We're branching into areas that we don't even understand now, which is wonderful. But tell us what it takes to work with your samples. If it takes a long time to analyze them, just be upfront about it. As long as you're communicating with us and we can justify why something's on a different timeline, we're able to do it. If you just aren't talking to us, we assume you're just delinquent and not doing it. We have links to the proposal deadlines again, and the links to the actual proposal form, which I'll go through in just a second. Again, I noted the executing the campaign. If you have a UAS, you will be required to do an aviation safety plan. This is really critical for us also to confirm you have the COA, everything you need to know, make sure that we've worked with the Forest Service on any particulars of where, when, and how you want to fly. That could also get into Columbus Air Force Base. So we just talk to us. We also deconflict. Like we were noting earlier, we're hoping to fly the TBS and the Arctic Shark sometime around at the same time or close to the same time. So if there's any deconfliction, we need to handle all of that appropriately. And again, closing out the field campaign we just talked about. On the right, we note how you can acknowledge ARM. If you're working with ARM and you have an approved field campaign and work with us. We have a link for principal investigators. This should tell you what you should expect when you're working with us, what's expected of you. Again, starts up front with your code of conduct. Anytime you have a field campaign that's approved, we need an abstract. We want to tell the community what you've proposed, and we're not going to release your proposal to the community. That's what the abstract is. The abstract's you telling the community what this is. There will be a campaign webpage that has this on it, and it will link to the guest instrumentation. So write this thinking about other users and what they need to know about the activity you put there, because they might want to collaborate with you, or they might want to use your data, or do something in the future. It's hard to say, but please, that's why we're asking. We're not trying to be a pain. If it's requiring a science plan, the larger campaigns, we do require that. And again, it's to communicate what you want to communicate to other users and the audience of what the intent of your science and the outcomes of that and the data related to it. Data submission, we do have a lot of guidelines in a couple different areas. We point you to the same area, but that provides you guidelines on how to submit data, and we'll hear more about this tomorrow. The final report, we do have templates based on the size of the campaign that you will have available to you to get started. And you could look at any of these other campaign web pages and look at their final reports if you want to get an example of different ones and what you might want to do there. Again, the acknowledgement, some special considerations here. This is back to noting the UAS considerations and why we're asking you so early for that, and communicating and linking to our observatories as well. Guest instruments, we've talked about a bit here, and instrumentation for offsite deployments, I don't think really applies to this group right now. On most of our websites, if not all, there are links on the right. Those are meant to be important to whatever the page is about here. It gets you back to the campaigns, the tethered balloon systems, the ARM facility call, and down there, the proposed campaign, the ISR form, which is the instrument support request form. We're trying to link it everywhere so you can't miss it, and it's all easy. It all does link to the same place though, don't worry. And then we put a couple things in here. Our aerosol and radar plans for the year, we link here, and the field campaign guidelines, and how to submit data. So we're just trying to make it easy for you to find things that might pop into your head as you're reading through these pages. This is the entire proposal form. If you really add this up, it's kind of like a one-pager. It does not have to be a 10-pager. There are some limitations, but it can get long. You're not required to make them long, please. So who are you? You do need to be registered with ARM to support this. That's just databasing. If you're going to do something with this, we get that done up front. Then what you want to do, where you want to do it, you get to propose a title, an acronym. They are subject to change. We can thank Rolanda and her crew for catching some that might be embarrassing, that we all were too literal and didn't think about maybe what we were putting out there, or copyrighted things is more often the thing. The when and where gives you a start and end date. You can have an ARM field campaign that has multiple intensive operating periods. We call them IOPs, but they're intensive periods within a field campaign. So you could have a 2-year field campaign, but say if you're very interested in the convection in the spring, you might have an IOP during the spring each year. We like to know those, and what ARM instruments are critical to you is another thing we ask you in here. And that's so we can make sure to time our calibrations, our instrument downtime. If we're concerned that we start seeing problems with an instrument, we want to make sure we're communicating to you that one of your critical instruments is down. It might be down for 3 days, and you could adjust because we're getting a repair done, and you can have that, you can be working with that instrument the next day. There might be things we could adjust, and there might not be, but we do want to communicate with you and try to schedule those things the best we can, so we're not impacting what you're doing. I think, again, scientific focus, relevance, that gets back to the mission. Those should be pretty self-explanatory. Your plan for what you're going to want to do, the best you can describe in here, if you're planning to physically come to the site, send grad students, the more you can explain to us in this, the better off we both are, because we can just plan it out and we can help you more the more we know about what you want to do. I will say occasionally we will catch in here, someone will say, this is my plan. They didn't include a guest instrument. We'll try to catch it. Things like that. It's just communication. We're trying to be reasonable here. The instruments, we want to know your guest instruments because, again, it is a requirement to get data from them, to get the instrument support request. If you don't fill that out and you bring an extra instrument to the site, you will not be allowed to deploy it. So please do not do that. It's rare, but it does happen. Again, the aircraft, if you have UAS that is non-ARM, this is where you click that box and it kind of puts it into a separate category, knowing you need an aviation safety plan. The site managers are going to want to talk to you as soon as possible, start working that out so that we can get it done. You will be responsible for your COAs. You will be responsible for the operation of your aircraft, but we will work on confirming that you have what you need to have. What you say you have should not be hard. Also, deconfliction. You will be responsible for your NOTAMs as well. Unless it's a very large field campaign that is written into the aviation safety plan, you'll be responsible for them. We want to know if you've proposed to ARM, say you've proposed a guest instrument, but it's related to another field campaign that is proposed to ASR, NASA, NSF, and you can't do your work if you don't get that other campaign. We want to know that this is contingent upon that. We still want you to propose to us. If it's an ASR or ESS, I was going to say FOA, NOFO, if it's an opportunity within the BER group, we will do a logistical review with what you provide us, and we'll provide that back to the program managers. And as they're doing the scientific peer review, it will just get sucked into that process and utilized there. So if you get an approval from them and you have a guest instrument or something related to on-site, it's already approved that way. We'll provide you a separate approval, but you don't have to do a separate review process or worry about that. It gets embedded. And then we do support proprietary things, but it is very rare. I haven't heard anything in here that would necessarily apply to, but check the box if it applies to you, and we'll work with you. So this is the campaign website. We will put it in the notes. There's other ways to get it. Again, you can go to the footer, click Propose a Campaign. It's going to take you there. And I think that's all I have. I do hope that there are some questions. But if not, it's getting late in the day too. Claps. Usually people just look really stressed after this one. Like, we have to fill out forms.
Are you going to share your slides?
Yes. We will share all these slides, and that's the best part about this is I like people to go to the webpage because I just go down the webpage. So but yes, we will share our slides. I believe we have UAH's slides. I think we have almost all the presenters, if not all of them already. So we'll make that available to everybody in the end.
I'm going to be that person. Nikki, does every arm.gov website have an Ask Us button at the bottom?
It does. And Geary, the data discovery has a feedback button, right? Or is it, no, support. On data discovery, click support. It's just like the Ask Us button. So we're trying to make it to where you don't have to go to the web page if you're not there, but you always have somewhere to get help on each of our pages. But yes, the Ask Us is on all of them. And if it's not, let us know, because that's not meant to be. Yes.
Hey, Nikki, are there any tools that show PIs how to submit PI data into the archive?
Tomorrow there will be presentations on this. The answer is yes. We have guidelines, we have tools, and we have people that will also help you. We have an online metadata editor form that tries to get all of your metadata straight and all coordinated so that when you put your data in, even before you put your data in, we have the ability to get your data visibility with the community. And so that also helps us. Giri will also explain tomorrow some about how we share data with other groups. So we have pretty sophisticated ways to share data that we don't actually have to share the data itself. We can share the metadata, we can link to each other's archives, we can make it visible to other communities like the Ameriflux community, the IMSL community, and still take our metrics. We are required by federal law to take our metrics and do what we were told there. So we need to do that, and a lot of other observatories or networks have similar requirements, across the world. So we're trying to make sure that we're sharing data in ways that helps everybody and fits everybody.
This time I won't ask an annoying softball. I just want to reiterate, if you are working on a proposal and you come across something that doesn't make sense to you, you're not sure about how you would ask it in an Ask Us request, please reach out to me or Nikki or Mike or Patty. Any way you can find our information, it's all on the ARM website, and we'd be happy to set up a call. I've spoken with several of you in this room over the last few weeks as proposals were due. Please do that, and we will help you as best we can, and if we don't know the answer, we'll find out who does.
Very good, and thank you. Yeah, we are very much hoping you all come up with new collaborations. If we know of something, we'll try to share it and help. If you know of something, please share with us, and we'll do what we can to connect everybody. Anything else? Okay, I think the remainder of the time here, you guys can mingle here, mingle elsewhere, talk to each other. Please share and collaborate. I really appreciate everything. And we'll see those of you who are participating tomorrow. We're still starting at 9 again. Is that still, oh, it's not up. I think we're starting at 9 again. I really do encourage anybody that's new to working with ARM, please try to attend. Thank you so much. The morning here, again, we're eventually going to try to make this into something that sits online. You can watch at your leisure, in your PJs. But right now, this is how we're going to do it. The virtual component is still there today. And then in the afternoon, we'll take the tour down to the site so you can see where everything is. Thank you all for everything today, and have a good night. Yay.